Hello, welcome to panel 2 of the Schiller Institute Conference for the Common Good of All People, Not Rules Benefiting the Few. My name is Jason Ross. I'm a science advisor to the Schiller Institute, and I will be moderating this second panel about the real science of climate change and why the world needs many more terawatts of energy. We discussed on panel 1 how economic development is limited in its potential by the basic infrastructure that is able to support the productivity of the economy. In Lyndon LaRouche's view, infrastructure platforms transform the space in which productivity occurs, enabling higher forms of production and transforming space itself through transportation networks. The most central component of an infrastructure platform today is, without a doubt, energy, power. It was the steam engine's liberation of the chemical energy in coal, transforming it into motion, that unleashed the industrialization of the world, a new era for mankind and economy overall, something that led to the expansion of life expectancies by a couple dozen years. Very, very impressive, extremely powerful, absolutely essential in economic history and in mankind's history. The development of electricity transformed the types of resources that were available to us, our relationship to those resources, the kinds of production that we were capable of engaging in, moving beyond motion towards new types, electron beam welding, lasers, and so on. The power of the atomic nucleus is still not fully developed, not by any means, but it shows us the potential to have power levels that are many orders of magnitude greater than what is achievable through chemically based electricity or wind or solar panels or that sort of thing. Potentially transforming through nuclear fusion in a very powerful way our relationship to the world around us in a way that would be comparable only to the development of the steam engine in its scope and in its potential. But it is power itself that is in the crosshairs of what was discussed in panel 1 as the Mickey Mat, as the British financial empire-oriented financial intelligence apparatus, where we are told that the planet is imperiled by the scourge of climate change brought about by man's wicked and unchecked use of fossil fuels, churning enormous amounts, we're told, of carbon dioxide into the atmosphere. And that these fossil fuels, which were absolutely essential for expanding the life of human beings by decades, must be phased out essentially immediately. And if you don't agree, well, how dare you? We're told that the science, with a capital S, is settled, that there's no room for debate on this issue, and even if we don't understand it, we better obey its strictures. That's not how science works. It's a process, it's development, it's a discovery. So on this panel, what we're going to be getting into is the coherence between our economic growth and the development of the biosphere as a whole, the enormous amounts of power that the world requires, and the gaping holes in the supposed science of climate change catastrophism. Let's start with a short quotation from Lyndon LaRouche about what the goal of society is. This is from a speech that he made in 2012. LaRouche says, "So the point is, we need every human being. We need them to live longer and better. We need them to be more creative. We need to have their children better educated and developed. We need an increase in the potential productivity of the human force per capita and per square kilometer, and those are the missions we must fulfill. There are many things we don't know yet, but these things we do know. The increase of productivity of labor per capita with an increasing population is the absolute necessity, which has to be coupled with the fact that mankind is no longer going to be content to sit on Earth and gossip about the neighbors. At this point, mankind is going to take an active role in taking over the Mars orbit. We are going to be inhabiting it with all kinds of instruments and so forth that we put there. We're going to learn how to control these asteroids that threaten us. We have a very poor track on it right now. We're going to learn how to use planets as communications devices in this process. These are the things we must do. And every step we take in this matter increases the productive powers of labor, makes people smarter, makes them more capable, gives them greater incentive, makes them happier. And that's what we must do. And all of these solutions, which are not solutions, they're actually threats. The green problem is not a solution to anything. It is a threat to humanity. Green people are a threat to humanity, he concluded. So to have the power to do all of these things, we're going to have to do a lot of work. And we have a powerful lineup of speakers who will be addressing this today, addressing economy, addressing carbon dioxide, climate change, nuclear power, nuclear medicine, and the enormous costs and negative returns of efforts to decarbonize without nuclear power. Our first speaker is Megan de Brood. Megan is the president of the U.S. Schiller Institute, and along with me and others worked directly with Lyndon LaRouche on a scientific and economic research project that LaRouche called The Basement. She has titled her talk today, Why the Universe Needs More People. Megan?
As you just heard, the title of this presentation states that the world, the universe, need more people for their continued existence. This is an idea that was first proposed to me by Lyndon LaRouche. It is not an opinion, but a conclusion derived from the rigorous study of the history of our planet and of the science of physical economy. However, not everyone agrees with that statement. Perhaps you've heard this. Human population growth is probably the single most serious long-term threat to survival. We're in for a major disaster if it isn't curbed. We have no option. Too many cars, too many factories, too much detergent, too many pesticides, multiplying contrails, inadequate sewage treatment plants, too little water, too much carbon dioxide. All can be traced easily to too many people. We are a plague on the earth. It's coming home to roost over the next 50 years or so. Either we limit our population growth or the natural world will do it for us. The good news is that the history of our universe and of the biosphere itself shows the opposite. There is no stasis that we are disrupting. There is no earth in the balance. Instead, we see a process of anti-entropic change, of intensifying transformation of the natural world, which created the conditions for the appearance of cognitive life and actually demands more people for that continuation. To get an insight into this, we're going to look briefly at the work first of Vladimir Vernadsky and then Lyndon LaRouche. So first, take most people's fallacies today about nature, the natural world to which human activity is supposedly opposed. Now, one of the big lines today that you may have heard is that we are destroying biodiversity and we're driving species out of existence 1,000 times faster than what is considered natural. Now, let's use the discoveries of Vernadsky to correct that view, starting with what a species of life is. There is no such thing as a living thing apart from the biosphere. That is, outside of the material and energetic environment in which it lives. You take a living thing out of the biosphere and it dies. This interconnection is seen in the fact that the body of a living organism, from the tiniest microorganism to the largest plants and animals, is not made up of the same material as it was last year, last month, or even yesterday. A living body is in an unceasing process of motion, exchanging material with the surrounding environment through its nutrition and respiration. Even you. roughly 98% of the atoms in your body today will have been replaced with new ones within the next year. Now, this led the naturalist Georges Cuvier to call a living organism an incessant current, a whirlpool of atoms which come from the exterior and return there. So, with that idea, we have a new view of a living species, not as a collection of things, objects with fur and feet and wings, but as something akin to a living mineral. If we take the totality of all individuals of a particular species across the globe, Vernadsky found that that species can be characterized by a mean mass, but more interestingly, a very precise distribution of the chemical elements and isotopes which make up its body, a distribution which is particular to that species of life, like a chemical fingerprint or signature. These living minerals, as long as they are in a process of exchanging material with the surrounding environment, they leave behind them, both in their waste products and also in their bodies when they die, they leave behind them a geochemically changed, transformed environment. My favorite example to offer here is the Great Oxygenation Event, which occurred somewhere between 2 and 2.4 billion years ago, which was shortly after the biosphere developed a new technology called photosynthesis. So at this time, these little microorganisms, cyanobacteria, began pumping out enormous quantities of oxygen into the environment, which was toxic to most life on the planet. This resulted in a mass extinction event in which an estimated 99% of all life on Earth died. But then, what emerged? Well, what survived mainly were the life forms that were able to metabolize oxygen. Now, this revolutionized the free energy that was available to living matter. It allowed eventually the development of mitochondria and multicellular life. Now, at the same time, the geology of the planet itself was dramatically impacted. New kinds of minerals began to appear, ones which could form in the presence of oxygen, including the banded iron formations. So, living matter has radically transformed the geochemical makeup of Earth, disrupting the non-living nature stasis around it. Because of this work, this activity performed by life, that Vernadsky called living organisms the bearer for and creator of free energy in the biosphere. Vernadsky's decades of work led him to two very important conclusions. Number one, that the action of living matter to reorganize the non-living material of the environment had gone on since the first appearance of life on Earth and had never ceased. Number two, the rate at which that had been happening has increased over time. Life sped up its process of changing nature. Now, this was something Vernadsky noted that was accomplished through the changeover of the ensemble of species that existed on the planet at any given time. In other words, this occurred through a process of extinction and evolution. So let's look briefly at one indication of that. These two charts show biodiversity over time. The top one is for tetrapod animals, and the bottom is for plants. Now, that line down the middle of both charts indicates the time of the KT extinction, about 65 million years ago when the dinosaurs were wiped out. What we see before that time is that the dominant classes of organisms were those with lower metabolic intensity, reptiles in the case of animals, and gymnosperms in the case of plants. Following the extinction event, those classes decline, and the set of higher energy organisms, the mammals and the angiosperms, emerge and take over. Vernadsky concluded from evidence like this that there is a definite direction to evolution, which is that of increasing the intensity of what he called biogenic migration of atoms. In other words, the intensity of the transformation of Earth by the action of living matter. So he said this moves over evolutionary time toward its maximum manifestation, so much so that were an organism to have evolved randomly, it would only survive if it could keep up with and contribute to the furthering of the intensity of the biosphere. So much for pristine nature, so much for the Earth in the balance. Nature is constantly changing, and it's changing in such a way that it is becoming more capable of future change. In this way, the biosphere, living matter, has acted to improve the Earth, to maximize the work done. It's concentrated materials into forms that are more usable and of a higher power than they could ever have been outside of the action of life. That is natural. But there's a limit to the biosphere. Evolution has allowed living organisms to penetrate deep into the crust of the Earth and high into the edges of the troposphere. But biological technology has been stymied at the edge of space, where the environment of the biosphere ends. However, over the course of the past few million years, the biosphere has developed to a point at which the emergence of a different kind of living form was possible, a living form not limited in the same way, and that is cognitive life. With humanity, we see for the first time the evolution of a species not via its biology. And Vernadsky makes a point to note that the biological and neurological infrastructure of the human organism has not changed appreciably over the past 10,000 years. And yet, look at how much our species has changed. Through the evolution of our mind, a type of biogenic migration of atoms, a type of exchange and reshaping of the Earth's chemistry has emerged as a significant factor, and that is the biogenic migration caused by technology, due to the organized labor, social work of a species. Let me give a couple of quick examples. One of the most significant in our history is agriculture, which began around 10,000 years ago when human beings began to select, cultivate, concentrate, and change plant and animal life to better meet their needs. This new reliability and also improvement of the sources of food and also of work, in the case of livestock, opened up the possibility of larger populations, permanent settlement, urban culture, and it also led to an increase in the productivity of various plant and animal species, which they could not have achieved without us. Another example is the application of fire to metallurgy, the extraction of metals from rock, and the shaping of them into tools. Throughout human history, we have created new things which could not and would not have existed otherwise on the surface of the earth. We've turned electricity into motion. We've enriched uranium. We've superheated and contained plasmas. We've applied the powers of these things in new ways, thus enlarging the natural world. This unique capability of man has allowed us to overcome the previous limits on our population. And Vernadsky notes that in the 1930s, the upper limit of the human population, he says, was probably around 3 trillion. Though he notes that with the knowledge of the atomic nucleus then coming into technological practice, it would likely become many times higher. So with the application of reason in the form of technologies, over the past 100 years, the noosphere, the domain of human activity, has begun to overtake the biosphere in its intensity, just as the biosphere surpassed the rate of activity of the non-living. And so our little planet's development was aimed toward and is now being cultivated to reflect the dominance of the power of reason. So we have, even with this small glimpse, the fact that nature is run by a creative principle. Everything participates in it, including the processes of the biosphere, which do so by instinct. Human beings participate in it consciously. And it's here that we turn to the physical economic discoveries of Lyndon LaRouche, which stand firmly upon the fact that human life embodies a higher principle of existence than that of mere animals. In his 1983 book, There Are No Limits to Growth, LaRouche writes, "Man is fundamentally different from the beasts. Man is not merely a creature of instinctive potentialities, a mere creature of animal-like perceptions of pleasure and pain. Man is somehow very different. Man has the potential of reason, the power to make creative discoveries which advance his scientific knowledge and to convert such scientific advances into advances in technology. We are able to uncover with increasing perfection the lawful universal principles which order universal creation, and to master nature with increasing power through guiding ourselves to change our ways of behavior in accordance with universal laws." As Lyndon LaRouche said many times, no animal has ever made a discovery of principle. Only human beings have. This is part of the goodness of mankind. Our minds are able to see, so to speak, by the generation of a creative hypothesis within the bounds of our own thought processes, we see principles of the universe, universal gravitation, electromagnetism, the powers of the atomic nucleus. These things could never have been seen or perceived with the animal senses. When we wield these ideas, these principles, as ideas embodied in technology, we are rewarded with new and efficient power to change the universe. There is the secret to economy. In a 2005 writing, Man's Original Creations, LaRouche says, "A foolish economist measures the performance of an economy in the financial or monetary, or much less foolishly, the physical wealth enjoyed by either some or all of the members of that society. The competent economist measures the wealth of the economy in the degree of self-improvement of the quality of the members of society as human. Making the same point more bluntly, it were said that the economic mission of society is to make the nation's people better than they are today. This is to be done through means employing the process of developing the people to higher levels of power in and over nature per capita. Or we might better say, the greatest wealth which the generation of the deceased has bequeathed to its heirs is a society of a better quality of living people. So, what is the primary input to a physical economic cycle? People, the labor and the supporting technology of society. What's the primary output? People, but a better quality of people. More people living longer lives, better situated to make the next discoveries and contributions to humanity. This is a self-perpetuating process. The universe indicates its approval of that process by allowing us, and in a sense, requiring us to do more of it. Based on this principle, Lyndon LaRouche developed a measure of physical economic progress that he called potential relative population density. How many people could be supported on a given land area were the available technologies and technological improvements applied to that land and to that population's labor? In a healthy economy, there is an increasing rate of increase of this metric. So, back to the biosphere, which is stymied at the edge of space. We are the only species that has the capability of transcending that boundary and extending the biosphere to other planetary bodies. When we do that, we will bring the same anti-entropic process of development that our planet has had the privilege to undergo deeper and deeper into the solar system and eventually to other star systems. Without us, life cannot do that. And perhaps that's one of the reasons that the universe created us. So I want to leave you with two thoughts. First, the idea suggested here by LaRouche of humanity's potential for limitless, unending progress. He says, mankind's physical capabilities are in and of themselves limited. The bounds of the human mind's power to imagine effectively from within the developing processes of not the human brain, but contrary to popular opinions, the human mind, have no presently adducible bounds. Second, the fact that unlike the biotic domain, which responds to its creative assignment automatically by instinct, humanity must choose to do the good. For Gottfried Leibniz, the fact that this had to be a free will choice is what made it good. Today, I ask you to imagine the goodness that would come to the billions of currently living human beings and the trillions waiting to be born if we were to root out forever from human culture the scourge of Malthusianism. Can we as humanity finally grow up and bring our behavior in line with our actual species characteristic? What great good will come when nations finally wield Lyndon LaRouche's discoveries of the principles of physical economy as conscious policy to shape the next 100, 1,000 years? Thank you.
Thank you, Megan. If you have questions for Megan about the topics that she covered or for any of our upcoming speakers, please send them in to us, questions@schillerinstitute.com. We will be taking your questions during the Q&A discussion period at the end of this panel. So our next speaker is going to be talking about Africa in particular in a certain way. The power needs for the nations in the African continent are immense. And how will this power be supplied? Windmills and solar panels? Will that be what we need to provide the many terawatts of needed additional power? Nuclear physicist Dr. Kelvin Kem speaks to us from South Africa, where he served as the former chairman of the Nuclear Energy Corporation of South Africa, and he's presently the director of Stratec Business Strategy Consultants. We're very grateful to Dr. Kem for making himself available, and Dr. Kem, go right ahead.
20 years ago, the world did not seem to have an energy problem. We didn't hear about all the snags we seem to hear about today. In fact, if we look back, we'll find that currently the world is using double the amount of electricity that was used about 25 years ago. 25 years and electricity has doubled. Now there seem to be all sorts of problems. Why is that? Is this because the scientists and engineers are not doing a good job? Why is it? Is it the case that somebody else is involved? Henry Ford, further back than 25 years, of course, was building cars and he had a factory going. He didn't seem to have an energy problem. When NASA was launching spacecraft into space to the moon, we didn't hear all the time about there's not going to be enough electricity to drive the economy. So we haven't had this problem until now. So what is going on? It appears to be that politics is interfering with the decisions that scientists and engineers would be making. Let's just imagine another topic for a moment. Let's take open heart surgery. Imagine now if there was this type of involvement. Imagine if we had a G7 agenda item deciding on open heart surgery, and the leaders of G7 are deciding how should surgeons remove hearts, how should the surgeons cut the arteries. Imagine if there was the equivalent of a COP26, everybody voting on heart surgery techniques. Surely you'd find people saying, wait a minute, why don't you leave heart surgery to the cardiac surgeons who know what they're doing? Tell them to do a good job and then judge them afterwards. Why aren't we telling the power engineers and scientists, provide the electricity and we will judge you? No, that's not happening. There seem to be energy problems all over the place because there's political intrusion. Now, why is there political intrusion like this? It's because decisions are being made on the basis of an argument that there's some climate issue involved. So therefore, there's something else. So you're not saying to the scientists and engineers, fellows, go ahead and produce electricity in the most reliable way at the best possible price. That's not happening. They're being told, you have to produce energy using wind turbines. You've got to produce it using solar power. But then you only get the sun in the daytime. And what's more, you only get the sun in the daytime optimally over a couple of hours straddling lunchtime. You only get less than 50% of the solar before morning tea break and after afternoon tea break. So even during the daytime, you don't get it all. So now what do you do at night if you've got a large solar investment? What do you do with wind power when the wind is not blowing? Then you come up with other solutions. You say, well, how about batteries? Why don't we come along and we put in hydrogen systems? Why don't we come along and put in this smart switching? So you have massive computerization, switching on, off, this turbine in, that turbine field out, this in, that out, and so on. All of the batteries, the hydrogen, the smart switching, smart grid, all this type of thing is coming about now to fix the system because the solar and the wind does not give adequate power. I must emphasize, I'm not in the slightest bit anti-solar and wind as technologies. If you have a use for solar like running a woodworking factory or something where you only need to use your large machines over lunchtime, and in the early morning you're doing your drawings and your layout, and in the afternoon you're gluing and forming, and you can design a consumption that goes up at lunchtime and down afterwards. That's fine. Similarly with wind, if you want to use wind to pump water up into water tanks and things like that, I'm not opposed to them philosophically. But when people tell you you can run large electric trains across the country based on solar and wind, then I say, wait a minute, I'm not so happy about it. So what has happened? We've had now this idea coming along that we have to save the planet. And save the planet means from carbon dioxide. So the carbon dioxide issue now is being determined by politicians. Supposedly, the CO2 is warming the planet. And everybody seems to believe this, or very many people seem to believe it, because they read it in populist magazines, and Leonardo DiCaprio and people like that tell you that that's what he's fighting for as well, and so do other film stars. But is this true? So we have to say, why is it that we're seeing this proliferation of wind systems, solar systems, and then batteries, and then hydrogen now, and switching and computer controls and all sorts of things now to try and take a power supply that inherently looks like a range of mountains and try and make it flat, that it looks like the open plains, because ideally you want a flat energy source that you can rely on all of the time, 24 hours a day, reliably, not something that may or may not be available. I must at this point out that electricity is sold in two different manners. One is the amount that you buy. That is measured in kilowatt hours. In the case of big systems, megawatt hours. But the other one is kilowatts, and that is how much is available right now when you switch on. That's the service element. We're forever seeing somebody say, oh, there's this new solar plant, it'll produce so many megawatt hours per annum. And it sounds impressive. Then they say, which will supply 20,000 houses or something. They don't say to you, only at lunchtime when you don't need the lights. That is a complete false type of impression. You need to know how much kilowatt hours can you get out of a system, but also how many kilowatts are available when you want to turn the switch on. If you get up at midnight and you flick the switch, you expect a service, and the service is the power must be there now. Electricity is not just a megawatt hours quantity, like buying milk. If somebody says you buy 30 liters of milk in a month, here in Africa where I am, we buy milk in liters, you fellows no doubt in pints over there in the US. But if somebody says, do you want 30 liters of milk per month? You say, great, on the assumption that that means a liter every day, not 10 liters on the 4th of the month, nothing for the next 4 days, 5 liters after that, nothing, then 2 liters, and so on. That is no good getting milk delivered that way. It's no good getting electricity delivered that way. So what is going on? This is supposedly now to save CO2 by cutting back on fossil fuel production through coal, for example. Gas is not in the same bracket, but it's also a fossil fuel that produces other things. So it's an interim measure. But they want to act against this supposed carbon dioxide. Now say to yourself, you flip a coin 50 times. How many times do you expect it to be heads, and how many times do you expect it to be tails? The answer is it'll come out 25 heads and 25 tails if you do it long enough. Why is it that somebody tells you we're getting global warming, and then all the results are going to be bad? In other words, you're going to get 50 heads in a row. We hear, oh, it's going to be drier in the dry areas. Oh, it's going to be wetter in the wet areas. There's going to be floods in the wet areas. All the animals will die in the dry areas. This is going to get worse. That is going to get worse. It's like flipping 25 heads in a row. Why don't we hear that if there's global warming, it means the dry areas will get some rain and the wet areas will get less rain, therefore there'll be less floods, and overall there'll be crops growing in places that couldn't grow crops before. That's the first clue to tell you that the people that keep punting this might not be right. Now let me make it quite clear. there is global warming taking place. There's been about 1 degree Celsius warming in the last 150 years, which is since the time that Abraham Lincoln was president of the United States, about the same time as Queen Victoria was queen in England, about the same time as the Crimean War. Now, the Industrial Revolution starting in Europe also happened to start around about that period of time. So why is it that every time we hear that there's been some global warming in the last 150 years, the phrase is used since the industrial age? The implication is it's because of the industrial age. They don't say it's because of Abraham Lincoln or because of the Crimean War. So why do that? It's a psychological trick to imply that the industrial age had something to do with it. It's not necessarily true at all. Yes, since the industrial age, there has been some extra carbon dioxide. But if you look at the amount of carbon dioxide that has been produced, you will find that a while ago, the concentration in the atmosphere was 0.03% of the total atmosphere. That's very, very little CO2. Now it has risen to 0.04%, a minute increase. Minute increase. Is that causing global warming? Now, I have my doubts. I really don't think so. In fact, if you look back at history, the temperature of the planet, you'll find that around the 1400s, there was a period, a medieval warm period, where grapes were grown in England. There were crops grown in Europe that can't grow now. The temperatures appear to have been warmer then than they are now. After that, the world plunged down into what is known in Europe as the Little Ice Age. It went very cold. In fact, the Thames froze over to such a degree that they were able to have ice fairs on the Thames, and they could ride up and down the river in horse-drawn carriages. You can't do that today. You know, this really is something that we need to think about. It's affecting society. People that have got small businesses, people that are running farms, people that are doing all sorts of things. They are part of the electricity system, in that electricity is the lifeblood of any country. Like a human being, if your blood stops flowing, you stop working. If the electricity stops flowing, the country will stop working. It's not something that you can allow the Greta Thunbergs of this world to go around waving banners and so on, when African children are having to dig the cobalt out of the ground by hand to build the batteries that they want, because they want a power source that is seen to be politically palatable for them. We really have to think a lot more. The so-called science is not settled the way some of the politicians like Al Gore and others like to stand up and say in this superior type of manner. It's not. There's much more to this than meets the eye.
Thank you, Dr. Kem, for your perspective and your sense of humor about things. The energy disasters that Dr. Kem described being brought about by demanding that the energy sector adopt political goals rather than engineering ones is something that we're seeing in a broad way in the transatlantic world, where the so-called leaders have been gushing about stringent goals for CO2 reduction, things like the Paris Agreement, these ongoing COP conferences, discussions recently at the G7 among central bankers, at NATO. You know, there's a lot of discussion about this. But when the people have the opportunity to make their voices heard directly, the outcome can be a little bit different. The citizens of Switzerland recently had just such an opportunity. 2 weekends ago, June 13th, they voted on a referendum that included a question about carbon taxes, about climate change measures. And they voted no. They voted no. Here to speak with us about this is Swiss mechanical and marine engineer, energy consultant, and president of the Switzerland-based Carnot-Cornot network, Emanuel Hoerner. Welcome, Mr. Hoerner.
I was asked by the organizer of the Schiller Institute panel discussion of coming Saturday to comment on the most recent polls in Switzerland with regard to environmental legislation. In a poll on the weekend of June the 13th, the Swiss population had to decide upon 3 proposals. All of them were in connection with environmental issues and all of them were rejected. For the understanding of some particular political instruments of Switzerland, the following. Switzerland knows at federal level the democratic instruments of referendum and the right of initiative. The instrument referendum gives the option to voters to reconsider and decide upon a bill which has already passed the federal parliament, which consists of 2 chambers. An optional referendum can be imposed within a given time period by demand of a minimum of 50,000 voters. A further remark, for the changes of constitutional acts as well as international agreements, a vote to a referendum is mandatory. A further political instrument is the right of initiative. Interested parties and circles can submit an initiative for changes in legislation if within a given time period signatures of 100,000 voters are submitted. The poll of June 13 also received particular interest from abroad. One of the subjects to be decided upon was a most stringent new CO2 legislation, upon which the Parliament had already decided. The referendum reached a majority of voters and counties, which means that the new CO2 legislation was rejected. The content of the CO2 bill was developed and governed mainly by leftish green interests and their ideology. Quickly, it would have led to a cost-driving measures, increase of fuel prices for vehicles, increase of fuel prices for heating purposes, taxes on flight tickets, constraints on house owners to refurbish their properties with regard to insulation and heating technique. Mainly because no more the use of fossil fuels would be allowed. As a result, rental costs would have increased drastically in a country where property renting is most prevalent. With this proposed legislation, the goal was to get Switzerland 100% CO2 free by 2050, which means prohibiting the use of fossil fuels. An interpretation of the result of the poll that the Swiss people do not care about the environmental issues would be entirely wrong. In Switzerland, we have stringent standards concerning heat insulation for houses, operational quality of house heating and vehicles, which include emission standards, amongst others also CO2. Quality standards which are regularly checked in short intervals and which have already been in place for years. Thus, one of the main reasons why the CO2 legislation under discussion was turned down. People lost confidence and were convinced that it would not improve anything with regard to the climate, however, increase cost of living and create an additional useless government administrative body. And also important to note, the younger generation was mainly rejecting the CO2 legislation. The slogan of the promoters was, "We are rescuing the climate." The absurdity of this claim under the precondition that Switzerland imposes such ruling isolated and alone may be illustrated by the following considerations. The contribution of Switzerland to the global CO2 emissions is about 0.13%. Assuming Switzerland is reducing the CO2 emissions from 2020 to 2050 on a linear scale to zero, the accumulated emissions over the period of 30 years or 10,950 days would be around 770 billion tons. The 3 dominating CO2 polluters, China, USA and India, produce this amount of CO2 within 16 days. A convincing policy to reduce CO2 emission can only work under the binding international agreement, which will have to be different from the loose Paris Treaty. The scientific field of climate is anything but in agreement about the triggering factors with regard to climate change. It may be that CO2 is one of them, but definitely not the only one. A possible other factor of importance is that mankind may need to learn and get used to a more careful handling of the limited resources oil, gas and coal. A further question needs to be raised with regard to what the claim of net zero CO2 could mean. According to the current varying energy policy in Switzerland, all of the 5 nuclear power plants must be taken out of operation until 2035. The missing power production is to be substituted by means of photovoltaic technology. Unfortunately, the need for construction material rises with the decrease of power concentration. Consequently, the accountable energy input for the construction of photovoltaic plants and the subsystems needed increases drastically, and thus the accountable CO2 emissions as well. Grey energy is the term used. According to my calculations, the substitution of nuclear production by photovoltaic and the mandatory subsystems as, for instance, hydro storage, the yearly accountable CO2 emissions will increase by 8.7 million tons, which means about 20% of the current Swiss CO2 emissions. This leads to the question, by what means could the use of energy from fossil fuels realistically be replaced? As said, not only in Switzerland, the prime option of the current policy is photovoltaic. If Switzerland would go for 100% decarbonization, meaning to discontinue the use of fossil fuels, one would need to invest in about 220 gigawatts of nominal photovoltaic power, about 20 times of the current electric power generation capacity installed. This figure includes also the replacement of current nuclear power plants, as well as to compensate for the power losses in the tremendous hydro storage capacity needed. It would be difficult to place this capacity in Switzerland, which is already saturated with hydro plants. Furthermore, time is getting short to implement all this until 2050. Consequently, there is only one realistic solution to ensure a cost-efficient power supply system in the future: nuclear power installation according to the latest state of the art. It will be a task for all of us to guide the European energy policy back to a reasonable track. Thank you for listening.
Thank you very much, Emanuel Hoerner, for your presentation. To further put climate claims in context, we have an emeritus professor of geophysics and president of the Climate Intelligence Group, Gus Berkut. He's from the Netherlands, a member of the Royal Netherlands Academy of Arts and Sciences, an officer in the Order of Orange Nassau, and a senior member of the Dutch Academy of Engineering. Professor Berkut. Okay, we're having a little bit of trouble getting Professor Berkut. I'll just reflect on what we just heard from Emanuel Hoerner about the vote in Switzerland. I mean, it's to be hoped that with discussions like this and people gaining a better understanding of what's truly required to make the energy that we rely on, people will have a better sense that simply saying we're going to do away with fossil fuels is going to leave us essentially with nothing. If we depend on solar panels and windmills, which according to some statistics are coming down in price, and indeed they are, they're improving, the issue becomes one of dynamics. What does it take to provide an entire system with the power that is needed for society?
My name is Guus Berghout. I'm Professor Emeritus of Geophysics at the Technical University of Delft. I'm one of the co-founders of the International Clintel Group, now consisting of almost 1,000 scientists. Clintel has recently written a letter to EU Vice President Frans Timmermans about the many incorrect assumptions and conclusions in the European climate policy. Clintel received the following response. Please read with me. We are already seeing the effects of climate change across Europe. Prolonged droughts and declining harvests, extreme heat waves, increasing diseases among livestock and crops, 400,000 deaths a year from air pollution and more. What an embarrassing answer. Why scaring people with lies and deceit? Hard facts demonstrate that the real world is entirely different. Let me show you the first factual graph. You see a spectacular drop in the number of victims due to weather extremes such as floods, droughts, hurricanes, forest fires, etc. A century ago, when there were 2 billion people only, weather disasters killed an average of about 500,000 people a year. Last year, despite an increase in the world's population to 7.6 billion, that number has dropped to an estimated 8,200 victims. So a decrease of over 98%, and measured per million people as much as 99%. This is impressive. Indeed, this is already a major achievement. But in the future, we can do even better. A further decrease of victims will be realized by increases in education, technological development, and wealth. The more knowledgeable and prosperous countries become, the better they can protect themselves from weather extremes. Let me show you the second factual graph. You see the global cost due to weather disasters as a percentage of GDP. Again, it shows a remarkable outcome. Even more so because the elites of the New Green Deal do tell us that the costs of climate disasters are increasing. However, in reality, the costs as a percentage of the global economy has not been rising, but it is falling. This happened at a time when CO2 emissions were rising faster than ever, despite the 25 international climate conferences that try to reduce them. Please look at this picture. Does it not show the absurdity of this climate circus? Let me also show you the embarrassing agreement of the G7 at the Carbis Bay Summit last week. As you see, their aim is net zero CO2 emission in 2050. I ask you, is this G7 plan a sign of stupidity, or is it a sign of evilness? Ladies and gentlemen, in conclusion, the factual graphs I showed demonstrate that there is no climate crisis at all. The latter has become the slogan of Clintel. But, ladies and gentlemen, there is more good news. In the next reality figures, I show you that more CO2 is even a blessing to nature and mankind. Food supply has increased by more than 30% since 1960. In this graph, you see that the grain yields have been tripled. You also see that the USA and China are doing very well. But this big achievement is also true for the entire world. So, the miserable Malthusian pictures of the past are replaced by a very positive outlook. Looking at all those positive developments, my question is, where is the climate crisis? Finally, I will show you even more good news. We see already for decades that more CO2 in the atmosphere is greening the earth, both being a global phenomenon. Look at this interesting picture. That the earth is greening is not a surprise, as many experiments have shown over and over again that more CO2 favors plant growth. The Dutch greenhouses are being fed with a surplus of industrial CO2 in order to increase their bioproductivity. Is it not a sign of pure wickedness to charge fees and taxes on CO2 generating activities, while this CO2 is a blessing to nature and mankind?
Thank you very much, Professor Berkut. You know, this graph that Professor Berkut brought up about the enormous decline in climate-related deaths, in climate-related damages, points to something that's incredibly important, which is that when we look at nature, you know, supposedly on its own, we don't understand things very well. So, key to the human species is the fact that we have increasingly developed an independence from the so-called natural or unimproved environment, and we've increasingly been creating our own synthetic, improved, nurturing environments where we develop agriculture, we've developed crops, we improve water systems, we improve drainage systems, we build our own infrastructure. Instead of relying on rivers for boats, we build roadways, railways, maglev lines. So the idea that nature is in some kind of perfect condition and that any changes to it are inherently bad is just the laziest thinking you can possibly imagine. It's like having a religious belief that you just go with without reflecting on it. So our next speaker, Professor Horst Joachim Lüdecke, is also an emeritus professor of physics. He's a professor of physics, informatics, and operations research at the Saarland University of Applied Sciences in Saarbrücken, Germany. His research has appeared in numerous journals such as the Climate of the Past, published by the European Geophysical Union, the International Journal of Modern Physics, and the Journal of Atmospheric and Solar Terrestrial Physics. He is the press director for EICA, the European Institute for Climate and Energy, and he brings to us his expertise in many of the ignored factors regarding climate change. There is more to understanding the Earth than CO2. His title of the presentation he's giving today is Climate Cycles and Global Warming. Professor Lüdecke.
Climate cycles and global warming. The best known climate cycle is a shift from warm periods to ice ages with a period length of about 100,000 years. It is known as way back as 2 million years ago and shown in Figure 1 up to 400,000 years before today, as seen in Figure 1. The data of Figure 1 were obtained from ice cores of the Antarctic. The time axis is in units of 1,000 years, or 1K, runs from right to left. At the top, the temperatures in blue are anomalies around the value of 0 degrees Celsius. These are Antarctic temperatures. It is noticeable that the warm periods are always much shorter than the ice periods. The cycle of ice ages and warm ages was already known approximately when the researcher Milankovitch explained it at the beginning of the 20th century with long-term changes of the Earth's orbit around the Sun. Modern climate research shares this hypothesis. Only the extreme brevity of the temperature increases after each ice age does not fit Milankovitch's explanation and is still a mystery to climate science. Temperatures over the last 10,000 years can be seen as a small stretch at the far right above. They fluctuate at most around plus minus 2 degrees Celsius. If you look again at the entire temperature curve, you can see that a new ice age must begin again shortly. In the lower part of the picture, the CO2 concentrations of the atmosphere are shown in green color. Striking is the synchronization of the CO2 concentration with the temperature. But the CO2 follows the temperature with a time lag of about 800 years, which is not really visible here. The cause of this apparent synchronization effect is easy to explain. Warm seawater allows CO2 to outgas, cold seawater binds CO2. So the temperatures are leading CO2, not vice versa, as it is attempted today by the global warming crowd. In Figure 2, only the last 10,000 years are shown. Again, the time axis runs from right to left. You can see in Figure 2 again a cyclical temperature gradient. This time the cycles are much shorter. They are between 1,000 and 1,500 years. You can also see that 4,000 and 7,000 years ago it was much warmer than today. Before our current warm period, on the far right, a cold period can be seen in blue called the Little Ice Age. It began in the 15th century and ended only in the middle of the 19th century. With regard to the term cold period, one may not forget that such times were very unfavorable for mankind without exception. Warm periods, on the other hand, were always beneficial. In the strong warm period 4,000 years ago, we saw the emergence of the great civilization at the Nile and the Euphrates. The wheel, writing, the plow, the sundial, and much more were invented in this warm period. Cold periods were always the causes of crop failure, famine, and epidemics. Figure 3 illustrates the implications of the Little Ice Age for the population, which was plagued by chilliness, poor harvests, famine, and epidemics. During the severe winters of the Little Ice Age, the Baltic Sea was completely frozen. Swedish troops, who were repeatedly at war with Russia at the time, crossed the icy Baltic Sea by foot several times with heavily packed wagons and cannons. Such a thing is almost unimaginable today. After the end of the Little Ice Age, around 1850, temperatures rose again quite naturally, albeit with intermittent relapses. Figure 4 shows the temperature curve from 1850 until today. The blue curve shows the thermometer measurements. The rising CO2 concentrations, colored in green, are considered by the IPCC to be the sole cause of the temperature increase. However, the agreement of the CO2 curve with the temperature from 1850 to 1975 is very poor. Only from 1975 to 2020 it is good. Over the last 20 years, from 2000 to 2020, the satellite data contradict the thermometer measurements. So for the last 20 years, the satellite measurements also do not show a good agreement with the increase of CO2. So is CO2 the only cause of warming or not? The media and politicians agree with the IPCC's view of CO2 being the only cause. Climate science, however, disagrees. The only undisputed fact is that the global average temperature has risen by about 1 degree Celsius since 1850. But this was to be expected, because after the Little Ice Age it had to get warmer again, otherwise we would still be living in the cold. If we now take another look at the course of the global mean temperature from 1850 onward in figure 4, we can see that in addition to the general increase, there has been a wave-like rise and fall in temperatures. Especially the cooling around 1975 made a great stir, which is often forgotten today. At that time, US climatologists feared the beginning of a great ice age, and the US media such as Time magazine reported on it as figure 5 shows. As a result of their firm belief in CO2 as a sole cause of the recent temperature rise, the IPCC climate models only take into account the effect of CO2, while natural cyclical climate variations are ignored in the models. The model results are correspondingly poor. The US climate scientist Professor Christie of the University of Alabama presented in a hearing to the US House Committee on Science figure 6, which proves the poor validity of climate models. It can be seen in figure 6 that no model represents reality satisfactorily. The IPCC climate models are therefore wrong. Nevertheless, they are the basis of climate policy in the USA, in the United States, Europe, and other Western countries. Now concerning the climatic impact of the sun and ocean cycles. In 2001, US researcher Gerald Bond published one of the most famous climate studies ever, which has been cited 3,000 times to date and has spawned countless other technical publications. In sedimentary deposits of the ocean floor, Bond discovered cycles of 1,000 to 1,500 years. Remarkably, these Bond cycles are still stubbornly ignored by IPCC reports. In fact, climate science considers the sun, which is so unloved by the IPCC, to be the most important clock generator of the Bond cycle. It has a climate impact with 4 parameters, which are listed in Table 1. This is total solar irradiations, TSI, ultraviolet fraction of TSI, the magnetic field of the sun, and sunspot numbers. The climate forcing by the sun is seen not only in the long Bond cycles, but also in solar cycles down to 11 years in length. The solar cycle of 11 years, the Schwabe cycle, is the best known of these. As an example of the numerous evidences for the sun as a climate driver, September temperatures of Holland are shown in figure 7, which is taken from a technical study of the author. One can see a good correspondence between sunspots and temperatures. The sun is here 4 months ahead of the temperature. Besides the direct climate influence of the sun, numerous and other natural ocean cycles have been discovered. And there's partly completely unknown. Table 2 shows a list of the ocean cycles which is not complete. We have here, first of all, the ENSO, which means El Nino, the AMO, Atlantic Multi-Decadal Oscillation, the NAO, North Atlantic Oscillation, the IOD, Indian Ocean Dipole, and PDO, Pacific Decadal Oscillation. SST in column 3 of table 2 denotes sea surface temperature, and delta P denotes pressure differences such as between the Azores high and Iceland low. To date, unfortunately, too little is known about how ocean cycles originate or even how they work. However, we increasingly know more about the effects on temperatures and precipitation up to several thousand kilometers away, and even worldwide distances, such as is the case with El Nino. Here are two examples. Example 1. It has long been suspected that the SST variations in the tropical Atlantic have an impact on rainfall in the central Amazon. A 2020 technical study by a team of researchers from German, British, and Russian universities explored these impacts in more detail. The study focused on the occurrence of droughts in the tropical Amazon. Hint-casting calculations were able to produce reliable drought warnings up to 18 months in advance, as Figure 8 from the study shows. Figure 8 shows in the upper part the standard drought index, SPI, in orange. If the SPI value falls below the threshold of minus 1.5, the broken red line in the figure, we have an extreme drought. The blue curve is the averaged cross correlations of the tropical Atlantic with the southern tropical Atlantic. If its value falls below minus 0.06, marked here with green cycles, a severe drought can be successfully predicted. Example 2. The precipitation in countries of Africa is in many cases significantly influenced by the ocean cycles and the sunspots shown in Table 2. In the specialized study of this year 2021, the nearly 120-year rainfall series of all African countries were examined for the influence of these cycles. The results allow to track rainfall events across Africa in time and space and to make partial predictions. Figure 9 shows this for the months September to December. One can see how the influence of different cycles and thus the rainfall intensity is shifting in time and space from September to December. Another spectacular result of the study is a cross-wavelet of sun and Ethiopian rain in Figure 10. Figure 10 shows an uninterrupted correlation between Ethiopian February rain and sunspots over 120 years. The sun signal precedes the rain events by 52 months. Summary. First, the sun and natural climate cycles can explain recent global warming better than anthropogenic CO2. Second, the IPCC ignores this, and for that reason alone, it is a political and not a scientific organization. Thank you.
Thank you, Professor Lüdecke. The complexity of the climate, given that we're trying to understand the entire Earth as a system which exists within a solar system and a galaxy, in a certain sense, it shouldn't be surprising that this is far more complicated than tallying up the contributions of one trace gas in the atmosphere, but it is presented that simplistically in many cases. In fact, that's how young people, to give one example, are pressured to do things like going on school strikes, Fridays for the Future, as though people of this age could have done enough work, maybe there's a few that are particularly exceptional, but as though the ability to understand these concepts in depth is possible for someone that young and without, a significant amount of work involved in this. So our next speaker, Professor Niccolò Scaffetta, is the final one of our presenters on the science of climate change itself before we shift gears to nuclear technology. He's a professor with the Department of Earth, Environmental and Resource Sciences at the Università degli Studi di Napoli, Federico II. He is leading and prompting a discussion of climate within Italy itself and within Europe and beyond. Professor Scaffetta will take us on a closer investigation of the climate models that are used to make claims about catastrophic change. Should these models be relied on to make decisions that will cost tens of trillions of dollars over decades and, given their enormous negative costs, cost millions of lives? Professor Scaffetta.
Good afternoon. Today I would like to talk about this topic, uncertainties about past and future climate change and economic questions. So we would like to talk about climate change and what is done. Now, about climate change, the first thing that we need to understand is that the climate is not constant. Climate has always changed in time. In this picture that you see here, you can see the historical data regarding the temperature of the Earth during the last 500 million years. And today we are here, and okay, we can go back on the past. So we will have here, there will be 150 years ago. This is 1,000 years ago, 2,000, 10,000 years ago, 250,000, 500,000, and then 1 million, 2 million, 3 million, and then 10 million, 50 million, 100 million, 542 million. And you can see that during this period, the temperature of the Earth went up and down many times. So there were periods like this one that were extremely hotter than now, about 8 degrees, also even about 8 degrees hotter than now. And then there were periods colder than now. And so it is evident that climate is not constant. But the important thing is that if we analyze this long sequence of data, what we see is that the data present a number of cycles, natural cycles that determine climate. So we observe cycles at about 150 million year period, about a 30 million year period, and then we find a set of cycles that are known as the Milankovitch cycles, 500,000 years, 100,000 years, 41,000 years, 21,000 years. And then we have a number of millennial cycles, and then we have a number of secular cycles like this one, 210 years, 115 years, and then we find the cycles at a multi-decadal scale, like 60 years, 20 years, and then we have the short cycles at few years of time. So, since climate is evidently regulated by a number of natural oscillations, it is necessary to reconstruct this oscillation to properly interpret climate change. And this is exactly what we would like to do. We would like to interpret this sequence here, this sequence, black sequence that you see here. This sequence is the global surface temperature of the Earth, and since 1850, and we would like to determine whether the climate models are able to properly interpret this sequence of data. The climate models are shown here in these colored figures. So I simply shift down the records to because to make it easier to see. And so what we see here is that the data are very complex, show a very complex dynamics. So we have a period where the temperature went up, then we have a period where the temperature went down, then we have a period where the temperature goes up, a period where the temperature goes down, then we have a period where the temperature goes up, and then we are more or less here, and now we are more or less in this point here. In these records, we have we have a warming, a clear warming. So from this point to this point, it is about let us say 0.9 Celsius degree of warming. This is what is known as the global warming since the pre-industrial age. But we don't see only a warming. We see that periods of warming and cooling, warming and cooling, warming and cooling. And when we talk about the economical policy, we need to talk about many things, such as Paris Agreement. So we have this agreement among the countries. So the idea was that we needed to keep the temperature below 1.5 degrees from the pre-industrial era. Because why? So because if the temperature increases above this level, this 1.5 level, so there is increasing risk, increasing environmental hazards. There are increasing environmental hazards, such that, for example, water security, coastal communities, and so on. So essentially, today we are here at about 1 degree above the pre-industrial era. We need to keep, according to this agreement, we need to keep the temperature below this 1.5 level. If the temperature of the world goes beyond this 1.5 Celsius record, so we enter in this red area where there will be huge problems. So the idea is that we need to keep the temperature below this 1.5 degree. But we will, when we will reach this 1.5 degree. And to do this, to be sure about this, we need to check. We need to check the climate models. We need to check the climate models. We need to check whether the climate models are correct. Now, the argument made by the IPCC that would confirm the validity of the climate models is essentially the one that is shown here. Essentially, what these models do is to run the models using two kinds of forcing. So we have the natural forcing. Natural forcing means the sun and the volcano. So beyond the sun and the volcano. And then, and what we see is that using just the sun and the volcano, the climate models produce no warming. So we have this level here in a pre-industrial level would be more or less equal to this level here, which would be more or less equal to this level here. So the climate models predict that natural forcing would produce no warming during this period. To get the warming, according to the climate models, we need to add the human forcing, the anthropogenic forcing, such as, for example, the forcing due to CO2. And what the models show is that there is an agreement between data and models, as you can see here. Okay, but there is a problem here. The problem is that these pictures actually do not prove what the IPCC would like to prove. So this picture suggests that 100% of the warming since the pre-industrial era is due to humans. However, the scientific method requires to compare the simulations with the actual data that correspond to the hypothesis of the simulation. What do we need to do? What needs to be done to validate the climate models is to look at the past. We need to see whether or not the models are able to reproduce the climate of the past. This is the main issue. So we need to look at the past. And what do we see if we look at the past? So we need to understand what happened during this period. We need to understand a little bit what happened during this period. In 2001, the IPCC alarmed the world. So what happened? It happened that the IPCC published this record of the global surface temperature of the Northern Hemisphere. And in this record suggests that the temperature was nearly constant for 900 years, from 1000 to 1900. And then since 1900, the temperature started to increase very, very fast. So there was this unprecedented warming. So this picture was published in Climate Change 2001, a scientific basis, and it was figure number 1 of the report. Figure number 2 of the report was this one, where they show the record of carbon dioxide, methane, and other greenhouse gases. And you see here that the same kind of pattern was observed here and here. So we have a hockey stick here, and a hockey stick here and here. So the argument made by the IPCC in 2001 was that the CO2 was the main cause of the rising of the climate, because there was this clear correlation between the records. And therefore, the IPCC alarmed the world about these things. However, what is not really known is that the IPCC continued to advocate the hockey stick temperature graph in 2001 and also in 2007, but in 2013, something happened. So in 2013, the IPCC abandoned the hockey stick. So the hockey stick was cancelled because it was considered essentially an illusion. And instead of the hockey stick, we had they published this graph that show a large climate variability in the past. So we see here a very strong medieval warm period and a very strong little ice age here in this period that was not present in this record. So this record essentially disappeared from the picture of the IPCC because it was found erroneous. Why this is important? So this is one of the new records that are published here, okay? So you see here that there is, that the hockey stick disappears, there is no hockey stick anymore, and there is a very strong millennial cycle. There is a very strong millennial cycle in this record. There is a warm period, we have a little ice age, we have a medieval warm period, and then we have this dark age cold period, and then we have this Roman warm period. So we have clearly a 1,000 year cycle in the climate. So there is this millennial cycle. So the millennial cycle, why it is so important? It is so important because it shows that the observed warming from the 17 to the present was mainly induced by natural causes, like the one induced by that were introduced in this 1,000-year cycle. Now, the big problem is that the models do not reproduce these cycles, do not reproduce any warm period of the past. And therefore, we cannot say that the models are able to correctly interpret the global warming observed from 1900 to today, because that warming could be due to natural causes that the models are not able to simulate. So, because, as I said, one needs to demonstrate that the models are able to reproduce the past, and if they fail to reproduce the past, they cannot be trusted for the future. And therefore, the situation is very simple from a scientific point of view. So the models are all wrong and do not use the right climatic forcing. And this is the same model. The same model is a zoom of the same models. You can see that the IPCC model are this green area. They indicate the IPCC model. The yellow area is this model that I produced in 2013. Actually, the model was produced in 2009. And so it was a prediction. You can see the prediction. The data, the black data are the data. These peaks that you see here are actually El Niño, so they have nothing to do with the climate change, with the long-range climate change. So these are just natural phenomena that have nothing to do with CO2. And but as you can see, the yellow model appears to agree better with the data than the green model. So because the green model ran too hot. That is an indication that the models are overestimating the system. Why there is also this problem in the models? So people are told that the climate science is settled. In reality, that is not true. Now, I would like to be very short, just 1 minute, because I would like to discuss regarding the credibility of this policy. So we have here that people, particularly in Europe, would like to reduce the emission to 0 by 2000, or reduce a lot. But the problem is that most countries are still increasing their emission. You can see here, this is from Europe. It's a document from the European Union, so the emission database from Global Atmospheric Research in Europe. And it is clear that while in the world there is an increase of emission in Europe, and there is a decrease, but that is just happening in Europe. And so the rest of the world are increasing. And I would like to end with this picture. This picture is very telling to me, because these are the new coal-fired power plants under construction or planned in the countries. And what we can see here, so the coal-fired power plants are the ones that emit the most of the CO2. Okay, so what we find here is that in Europe, in Western Europe, there are no new coal-fired power plants. In the United States and Canada, there is nothing. But as you can see here, if we look at the Asian side of the world, in China, India, Indonesia, but also Japan, Korea, South Korea, and so on, they are building a lot of coal-fired power plant. So it is obvious that if Europe or United States decrease greatly their emission, it is obvious that while the Asian countries are increasing so much the coal-fired power plants. So it is obvious that there is no way to reduce CO2 in the world. So the CO2 would increase, and the only effect of this policy would be to impoverishing Europe and the United States. Said this, so my conclusion, the models on which the anthropogenic theory of global warming observed from 1850 to 900 is based are not scientifically validated. So they contradict each other and therefore cannot be considered reliable for future climate prediction according to the various emission scenarios proposed by the IPCC. So the evidence from the data is that there are large cycles. These cycles can be actually fit to astronomical forcing, such as solar forcing. But this factor, these mechanisms are not present in the models. So the models needs to be greatly improved. They are not really credible. The inclusion, however, of natural climatic cycles and part of non-climatic warming, such as also the effect of the cities. I do not talk here about the effect of the cities. Can reduce the effect of the anthropogenic component, can reduce from 50 to 60%. So there will be a huge reduction of this impact that humans can have on the climate. The observed warming from the pre-industrial area could be due to 50% to the sun, 30% to man, and 20% is a spurious warming because of urbanization and urban heat that is not correct yet in the climate data. And so I would like to thank you for the time. Thank you.
Thank you, Professor Scaffetta. You know, it's interesting that one of the components that Professor Scaffetta and also Ludica and actually a number of our speakers have brought up is the impact of the sun on the Earth's climate. Now, in a certain sense, you shouldn't be surprised that the sun has a major effect on the Earth's climate. It's pretty important. One of the ways that I've seen, videos try to debunk this claim is to reduce it entirely to the amount of heat coming from the sun, or total solar irradiance. And this leaves out the work of people like Svensmark from Denmark, Nir Shaviv in Israel, who've looked at the relationship between galactic cosmic rays striking the Earth, which form cloud condensation nuclei and help to form the level of cloudiness in our atmosphere. And of course, clouds reflect sunlight. A lot of clouds means a cooler Earth. Well, the amount of cosmic radiation reaching the Earth is modulated by the magnetic field of the sun, and its activity is measured in such things as sunspots. So it's there's amazing sort of how many different processes interact on this level. In this sense, the sun is modulating it. It has an effect on the Earth, but the mechanism that the sun is modulating is actually cosmic radiation coming from somewhere in our galaxy. So it's pretty phenomenal to look at the Earth in its broad context and to think that these huge processes actually do impact us in a significant way. So we're going to turn now to a short greeting to the conference from a civil engineer, John Shanahan, and he will introduce himself in his short message. Go ahead.
Hello, my name is John Shanahan. I'm a civil engineer living in Denver, Colorado. I would like to thank Mrs. Helga Zepp-LaRouche for organizing the Schiller Institute Conference on Avoiding World War III and inviting me to participate. I started my professional life as a civil engineer in commercial nuclear power in 1970, and then became interested in public education for broader topics of energy in general, nuclear science, the environment, and the human factor. It is clear to most engineers that solar and wind power are too diffuse and incapable of providing energy for the modern global economy. So to counter the disinformation in the media, some friends, associates, and I began a website, allaboutenergy.net. I am determined that our knowledge will not be lost. I am helping students in Latin America, Africa, Europe, North America, and Asia, learn about the importance of reliable, affordable, high energy density energy sources, fossil fuels, and nuclear power. I have lived a total of 10 plus years in Germany and Switzerland in the 1960s and 1980s, working directly with Europeans in German, and visited Friedrich Schiller's burial place in Weimar. Since 2007, my wife, friends, and I have bicycled in Europe for 2 weeks each year. We are familiar with the strengths and weaknesses of governments in Europe and North America, and by extension, governments around the world. Since the 1980s, I have traveled to Latin America for backpacking and visits with friends in Bolivia. I am familiar with literature of that interesting part of the world. The website, allaboutenergy.net, is a holistic educational effort about energy, environment, energy byproducts, nuclear science, and their importance for the modern world. A greatly revised and updated version of the website will be released in a couple of months. We have an international board of advisors, 44 people from 18 countries. The website has about 2,200 articles, reports, PowerPoint presentations, ebooks, and videos for public education. The volume of content is constantly growing. We have a newsletter that is sent to people in 124 countries. Our mission is similar to the Schiller Institute's. We focus on the next 200 years. The Schiller Institute focuses on however long humanity will play an important role in the universe. We look forward to working together, and thank you very much.
Thank you, John. Taking a lead from that endorsement of the Schiller Institute, I'd like to encourage everybody watching, if you aren't already, to become a member, a sustaining member of the Schiller Institute. You can do so by going to our website, schillerinstitute.com/membership, where you will see this page. You can enter an amount that works for you per month and sign up and make an automatic contribution every month to provide a dependable support for the Schiller Institute. Our sustaining members also have access to a monthly members-only private Zoom call with Helga Zepp-LaRouche, where you get a chance to have a discussion with her. So please join us at schillerinstitute.com/membership. We will turn our attention now to nuclear power, nuclear science, and some of the benefits that it provides to humanity. The first speaker on this might be in a field you didn't expect, namely nuclear medicine. People think about Chernobyl and they think that nuclear power, nuclear radiation in general has an immediate and devastating impact on your health, or at least a bad one. But that's not true. Nuclear science and our study of radiation has dramatically improved our ability to treat many health conditions, as we will learn from our next speaker, Dr. Bennett Greenspan. He is on the board of directors of the American Board of Science in Nuclear Medicine, and he's the past president of the Society of Nuclear Medicine and Molecular Imaging. Dr. Greenspan will speak on the topic of Introduction to Nuclear Medicine. Dr. Greenspan.
Hello, I'm Dr. Bennett Greenspan. I'm going to be giving you an overview of nuclear medicine. Now, nuclear medicine is the medical specialty that uses radiopharmaceuticals and the tracer principle to evaluate molecular, metabolic, physiologic, and pathologic conditions of the body for diagnosis, therapy, and research. Radiopharmaceuticals are basically drugs that are labeled with a radioactive isotope. And we use the tracer principle, which means we give a trace amount of this radiopharmaceutical, and we can trace how the body will metabolize it or digest it or whatever. And these are very tiny amounts of radiation. They're very safe. And we've been doing that in this we've been using these in this field for 80 years, and with very good results. Most nuclear medicine studies are diagnostic and evaluate physiologic characteristics or function of various organ systems. And the major purpose of nuclear medicine is to show function or physiologic characteristics. Radiopharmaceuticals portray the physiology, biochemistry, or pathology of a body system without causing any perturbation of function. They are referred to as radiotracers because they are given in subpharmacologic doses that trace a particular physiological or pathologic process in the body. Images in nuclear medicine are formed by administering a radiopharmaceutical, usually intravenously, and images are acquired with a scintillation or gamma camera, or for PET studies, a PET camera. And acquisition of images requires careful quality control of radiopharmaceuticals and instrumentation. There are several types of imaging, which I've listed here. Now, I'm going to go through a few common studies that we do, that we perform. One of them is bone scintigraphy. There are many indications. So here's a normal bone scan. Here on the left is the anterior view, and on the right is the posterior view. And you can see that they're different. Here is an example of metastatic prostate cancer, where all of these dark spots, except for the kidney here, and the kidney here, are abnormal. Here's an example of osteogenic sarcoma, where the primary tumor is in the lower part of the right femur. In another common study we perform is brain imaging. There are a number of indications. Two of the most common are dementia and epilepsy. And here's a normal brain scan. And with this is a PET study, and the tracer distribution or metabolism that we're looking at in the brain is relatively uniform throughout the cortical margin here, the cortex of the brain. And here is a case of Alzheimer's dementia, where it's not uniform and there's decreased metabolism posteriorly here in the parietal lobes. Okay, now as far as tumor imaging, there are a number of indications: identification, screening or diagnosis, staging and restaging, identification of recurrence, residual disease or surveillance, monitoring response to therapy, and evaluating prognosis. Now, PET-CT is one of the major modalities for imaging a tumor. We can also image studies in cardiology and neurology, but the vast majority of PET studies, or PET-CT, are in oncology. So here, and I'm going to show an explanation of how this works. And a nucleus gives off, is a positron emitter and gives off a positive electron, beta plus. And when a positron is given off, it combines with an electron, and they both annihilate each other and produce gamma rays in equal and opposite directions. And this is a better slide that shows that. We use what we call annihilation coincidence detection. So if these two detectors detect gamma rays equal and opposite to each other at the same time, they presume that there's an event that occurred in between. And so and this technique has better sensitivity and resolution than the conventional nuclear medicine gamma cameras we've been using. It also provides accurate quantification. And normally we can use short-lived positron emitting radionuclides. And so these are radioactive isotopes. Angelic carbon, nitrogen, oxygen, and fluorine are the common ones. Now we take advantage of glucose metabolism, and we label glucose with a fluorine 18 atom on here. So this is fluorodeoxyglucose, because we take off an oxygen, put on a fluorine 18, so we can do the imaging. And this is kind of how it works. The fluorine 18 goes up to the cell, and the cell takes it in through these glucose transporters, and it gets in the cell, and it starts getting metabolized, and then it gets stuck. So it stays in the cell, and that's why we can image it. And it turns out that most tumors, especially malignant tumors, need more glucose than normal cells. And so fluorine 18 FDG was labeled the molecule of the century in the last century, in the 20th century. And I think rightly so. So here's an example of a patient with lung cancer using this technique. Here's an example of metastatic melanoma. And this usually produces little tiny dots like here in the spine. Here's an example of cervical cancer with extensive metastatic disease throughout the bones. You can see in the ribs, sternum, both arm bones, the humeri, and both leg bones, the femora, and in the pelvis. Now, the next item I wanted to talk about is radiopharmaceutical therapy. I said initially that most studies are diagnostic, but radiopharmaceutical therapy is currently the hottest research area in nuclear medicine. There are a number of radiopharmaceuticals we're using, and new ones are being tested every day. Now, we've been using iodine-131 sodium iodide for thyroid disease since the 1940s to treat hyperthyroidism and thyroid cancer. That still works very well. In 2013, radium-223 dichloride, which is an alpha emitter, was approved for treating castrate-resistant metastatic prostate cancer, and it's had some success. One of the industry companies said that currently now we're using about 13% of nuclear medicine procedures or therapies. They predict that's going to rise to 30% by 2030. So this area is really, really hot stuff, and it's expanding exponentially, and we're getting some good results. So we have iodine-131 sodium iodide for hypothyroidism, for various thyroid cancers. We have somatostatin receptor targeted therapy for neuroendocrine tumors. We have another agent for neural crest tumors, and coming soon will be an agent for prostate cancer. This is one being studied at the Peter MacCallum Cancer Center in Melbourne, Australia, and this was the image of the year in 2018. And the areas in red are tumor, and the image on the left is before therapy, and the image on the right is after therapy. You can see there's some incredible results here. This agent is being used in Europe and Australia and Asia, and hopefully it'll be soon approved in the US. Here's another example where we can use imaging to detect tumor and then before and after treatment. This agent now has been approved for imaging. And here's an example of PSMA therapy. This is the imaging agent was just approved very recently, and you can see the vast improvement after therapy. The therapy agent is not yet approved in the US, but we think it will be within the next year. Here's an example of a patient with thyroid cancer that didn't respond very well, and now we can use a certain drug that will help reverse the process and allow these lesions to show up, and so we can then treat them. This work comes from Memorial Sloan Kettering in New York. Here's an amazing slide showing, this is work in Germany, where someone had extensive prostate cancer disease, and the PSA was very high, and they treated the patient with lutetium-177 PSMA, and the patient got worse. So they thought, well, we need to use a different agent. So they used actinium-225 PSMA. It's attached to the same molecule, but it's a different isotope. And after 3 cycles, the PSA went down from 294 to 419 to less than 0.1. That's an amazing result. So in the near future, based on biological characteristics of tumors, we will be seeing increasing use of predictive and prognostic markers, assessing therapeutic response and focused surveillance and screening. This comes from Dr. Lalitha Shankar at the National Cancer Institute. Tumor heterogeneity is a key factor limiting response to targeted therapy, and personalized or precision medicine depends on biomarkers for selecting patients and directing radionuclide therapy. Now, Dr. Richard Baum from Germany came up with these comments, and I think he's a visionary. I think he's right. Eventually, we're going to be classifying cancers by molecular phenotypes, and the organ of origin will be a secondary classification. And these molecular phenotypes will be determined by molecular pathology and by molecular imaging, using our PET and SPECT studies and other imaging techniques like MRI and optical, and using cancer type specific probes. This is what precision medicine will become. So I think possible future approaches are listed here. I think I probably shouldn't go over all these because it's pretty complicated. So I predict in the future that future developments in cancer therapy will include specifically targeted or precision radiopharmaceutical therapy with combinations of alpha and beta emitters, probably as theranostic pairs. Theranostic means a combination of diagnosis and therapy, targeting of various enzymatic pathways and cell surface receptors, including clonal variations, to address the variation in tumors. These radiopharmaceutical therapies will also rely on precise dosimetry, probably including intralesional dosimetry, in other words, dosimetry of actual tumor deposits. These radiopharmaceutical therapies will provide more precise and comprehensive therapy and lead to much improved outcomes and less morbidity. And I believe that's my last slide. Thank you very much.
Thank you, Dr. Greenspan. That was quite a variety of different isotopes used that you just described. I think there might be some questions about that in the discussion period. Speaking of the discussion period, just to give the lay of the land here, we have another greeting to the conference from a PhD student. We have a presentation from Paul Dreesen, and then we have an introduction that will lead into our discussion period with another nuclear scientist. So let's hear from a PhD student in nuclear science and technology. She's currently in China. She's from Mexico, Florencia Renteria.
Thank you very much. Well, my name is Florencia Renteria. I'm from Mexico. I'm 20 years old. Currently, I'm doing my PhD in nuclear science and technology in China at Harbin Engineering University in nuclear science and technology. My specialty is advanced reactor physics. And before, I went to South Korea to study my master's in nuclear power plant engineering, where I specialize in nuclear core design. And from Mexico, I got a bachelor's degree in chemical engineering. For some time, I worked in mining industry in Mexico, but after it, I went to Korea. Well, for me, I really like to study and to do things related to nuclear science because I think it's a wonderful field where we can specialize and spread the benefits of the nuclear technology. I'm from the north of Mexico, from the Coahuila state. So in my hometown, there is one of the good universities where you can study engineering. And before I was finishing my high school, I was thinking, what should I go to study for a bachelor's? Then I was thinking chemical engineering could be a good choice because one of my aunties, she's a chemical engineer. And I just got inspired, part of it from her, and also from my chemical classes during the high school, because we had a good teacher. She was amazing, the way she was explaining chemistry, and she was motivating people how chemistry is everywhere. Even she was preparing her own chemical products and selling to the people. Then I thought maybe it could be a good idea. And I just started looking at some areas where I can develop myself in chemistry when I was doing in my studies in high school. And I found out chemistry is one of the main areas that are in the industry. And it gives some flexibility to work in other areas. After the college, when I finished my career, I did one of the specialties in extractive metallurgy. It's part of the mining industry phases. That's how I got into mining industry. I did some internship, and it was pretty amazing how people are extracting minerals and converting it into different parts of the technology, even computer, cars, etc. And it was like a great opportunity also to be there. But after I finished my internship in mining industry, I got the opportunity to go to Korea to study the specialty in nuclear engineering. And at the beginning, it was a little bit hard to change my mind because I was planning to develop myself more in chemistry and mining industry. But some challenges comes through the life. And I thought, why shouldn't take the chance to go for nuclear industry? And I found out it was amazing because you can combine what you know from chemistry with the new things in nuclear engineering. I was just like pretty new in the field. I had to start from the scratch in South Korea, so many things, because I didn't know many concepts. But I was pretty lucky because the school where I studied in Korea, they really train you from the basics to understand and learn the overview of the industry. And that's how I end up doing my PhD also, because I got inspired and then I said, I want more, like to study other competencies to cover my knowledge and keep developing my skills. I think yes, history takes an important role in our lives and decisions, of course. And now that you're just recalling our past role models, was in my high school. We took the literature class, and every month we have to read at least 3 or 4 books, because at the end of the month we will take an exam and we will write questions about how was the lesson learned from the books. And I will say this part of the reading time helped us to develop our personal and interpersonal skills, because sometimes we tend to be shy, or sometimes it's hard to express ourselves. But like through Shakespeare, through Quixote, I don't know, I remember just Albert Camus is one of the books that we read, Homero from the Greek culture. So we have to understand their vision in that time and which were the challenges. And we were analyzing in the classes how we can take it into the current stage. For the next years, I really like to promote more programs for graduate students. I know sometimes back in our countries, or even in our countries, all the educational system is not created for all of us to go for graduate education. But I'll be very happy if at least from the people who are graduating from bachelor's, at least half or 20 or 30% can go for a master's degree, because we end up very few people doing a PhD. And it's not like it's hard. I mean, it's just constancy and being disciplined. But I'll say, or at least help people to develop their talents, what they are good doing it, and how they can adjust or contribute to the world. And maybe also see other policymakers adjusting their educational plans, maybe for more energy topics, because I discovered, well, it's not I discovered, but according to the random opinion of more people, now is more expressed the positive thoughts to nuclear energy, but not everyone shares the same opinion. But at least they can go through it, they can understand what is nuclear, or how they can adjust to many other energy sources to create sustainability in all the world. I think that will be the plan for the next 10 years. And if every other student can have the opportunity, as I had, to go to Korea or come to China, or even in their own country, just to keep developing their talents, maybe create a system of scholarships for everyone to develop their abilities. For the next 50 years, well, I'll be very happy if we can reach the fusion, the fusion projects, and to see in more countries like a green economy, where everyone can have a perfect balance of energy. There is still a lot of countries, like African countries or Asian countries, where they don't have access to electricity or water. Those are essential services for having good quality of life. So if we cannot have electricity, we cannot learn, you cannot use internet, you cannot even have access to a smartphone. So for some of the people, it's a big dream to have this. For some of us, we have the privilege to have it in our daily life. But at least if everyone can have the available tools in the next 50 years to keep developing themselves and create the synergy and good projects to keep developing technology of their own countries.
Thank you, Florencia Renteria, PhD candidate in China. You know, the fact that many countries in the world right now don't have the opportunity to really engage in nuclear studies domestically is a shame. I mean, the potential of the nucleus that was first really, explored and its potential seen in the late, in the 40s, 50s, 60s, the fact that the growth of that potential source was curtailed and that its development is now a source of fear rather than an opportunity. One of the aspects of this is not only the bad effects it has on energy and everything else, but also the fact that it is stifling the opportunity of thinkers to go into this field and make the contributions that are going to be necessary to have totally new scientific breakthroughs and technologies coming out of a better understanding of the atomic nucleus. So we will turn now to our final speaker before we move to our discussion period. We have Paul Driessen, and very happy to have him. A lot of times in the climate discussion, things are presented as a yes or no. Do you believe in climate change? Instead of saying, well, how much? Or due to what causes? And then when it comes to the economic issues about what to do to try to prevent it versus what are the costs of not caring and saying, well, maybe we'll have to run the air conditioner a little bit more, that's actually a complex question. It's not simplistic. So to address those issues and more, we have Paul Driessen. He's a senior policy advisor for the Committee for a Constructive Tomorrow, CFACT. He also works with the Heartland Institute, and he is the author of Eco-Imperialism, Green Power, Black Death, which is a book. So speaking to us today on the Biden AOC Green New Deal fraud, unsustainable, unaffordable, eco-destructive, carbon colonialist, we have Paul Driessen.
Good afternoon. It's an honor to join you today, and I look forward to engaging with you more personally during the Q&A. The proposed Biden Green New Deal is so all-encompassing, deceptive, and destructive, we could spend weeks discussing it. Just addressing the junk science and useless climate models behind it would take days. So this afternoon, I'm going to focus on 6 myths or scams about fossil fuels, carbon dioxide, and supposedly clean, green, renewable wind and solar and battery energy. Green New Deal scam number 1. Fossil fuels, coal, oil, and natural gas are evil. We need to get rid of them right now without resorting to nuclear power or damming more rivers for hydroelectric power. What a crazy idea. Fossil fuels built the United States and developed world. They're the foundation for our industries, jobs, living standards, revenues, healthcare, and countless other social, economic, and environmental benefits. They still account for over 80% of America's and the world's total energy. To suggest that the United States could or should make them disappear and somehow replace them with renewable energy is sheer insanity and fantasy. Scam number 2. Carbon dioxide is poisonous, an existential threat to humanity and planet. Absolutely ridiculous. Carbon dioxide is the miracle molecule, the gas of life. Yes, it comes from burning fossil fuels, but it also is what humans and animals exhale and what plants absorb and use to grow and release oxygen. CO2, or carbon dioxide, makes life on Earth possible. More CO2 in the atmosphere enables plants to grow better and faster, even under adverse conditions like limited water, hotter air temperatures, and insect and other infestations. These enhanced rates of photosynthesis and biomass production occur for virtually every kind of plant, every part of the plant, in every ecosystem, and on every continent. Higher atmospheric CO2 levels mean higher crop yields, so that more people have greater quantities of nutritious food from less land and with less water. Higher levels let plants absorb carbon dioxide through smaller pores in plant tissues, improving water use efficiency and helping to green desert areas like the Sahara. By contrast, if we had to feed the world and replace oil and natural gas fuels and petrochemical feedstocks with biofuels, we'd have to plant biofuel crops on millions of acres that are currently food crop fallow, scenic and wildlife habitat lands. Hundreds of plant and animal species would simply disappear. These enormous benefits vastly overwhelm any conceivable harm from carbon dioxide's tiny role in natural climate change and extreme weather. Green New Deal scam number 3. We can easily replace fossil fuels with renewable energy. Not a chance. Wind and sunlight absolutely are clean, green, renewable, and sustainable, but harnessing them to meet humanity's huge and growing energy needs is not. Harnessing them requires mines, lands, and raw materials that are anything but renewable, using fuels and methods that are absolutely not clean, green, ecological, or sustainable. President Biden, Ms. Ocasio-Cortez, and their political, media, and corporate allies want the United States to have 80% hydrocarbon-free electricity generation by 2030 and 100% by 2035. They want to totally eliminate fossil fuels from all sectors of the U.S. economy by 2050. They want to replace our reliable, dispatchable, affordable coal, oil, and natural gas energy with expensive, intermittent, weather-dependent wind and solar power. Their Green New Deal requires replacing coal and natural gas for generating electricity, gasoline and diesel for powering vehicles, natural gas for smelting and manufacturing, natural gas for heating, cooking, and water heating in homes, hospitals, schools, and factories, and businesses of all kinds. Together, this would mean the nation's annual electricity requirement would skyrocket from about 2.7 billion megawatt hours, which is the fossil fuel portion of total U.S. electricity generation in 2018, to almost 7.5 billion megawatt hours a year by 2050. Substantial additional generation would be required to constantly recharge backup batteries for windless, sunless days and safeguard society against cyber attacks and blackouts. Generating all that electricity without new nuclear and hydroelectric plants would require tens of thousands of 800-foot tall offshore wind turbines, hundreds of thousands, maybe even millions of somewhat smaller onshore turbines, and billions of photovoltaic solar panels. Backing up sufficient nationwide electricity for even 1 week of windless, sunless days would involve well over 1 billion half-ton battery modules like those in Tesla cars, so that blackouts don't shut down our economy and lives. Connecting all those facilities to energy-dependent communities, industrial centers, and data hubs would require thousands of miles of new underwater and onshore transmission lines. These are incredible numbers, to be sure, but that's because wind and solar generate electricity only 25 to 50% of the year in the best U.S. locations, and less than 33% on average nationwide. It's because the more wind and solar electricity we need, the more we have to put turbines and panels in lower quality areas where they might generate power only 15 or 20% of the time. Hundreds of millions of acres would be impacted, a huge swath of the continental USA. Looking more closely at offshore wind energy, President Biden wants to install 30,000 megawatts of wind power off America's coast by 2030. That's over 2,000 monstrous 14-megawatt turbines. Even if they operated at full capacity 24/7, these turbines wouldn't meet peak summer electricity needs for New York State, much less the entire USA. Just as crazy, in a Green New Deal United States, we'd have to throw out trillions of dollars worth of still perfectly good fossil fuel generating and industrial systems, home furnaces, stoves, and water heaters, gasoline and diesel vehicles, and other equipment that are far from the end of their useful lives, and replace them with electric versions. We'd also have to expand and upgrade home and business, community, state, and national electrical systems to handle the added power demands and fast-charge electric vehicles. That's more trillions of dollars, tens of thousands of dollars per family. Even if wind and solar facilities avoided the most highly sensitive ecological areas, they would still disrupt or destroy scenic areas, croplands, and wildlife habitats. Turbine blades would kill millions of birds and bats. Vibration noise from offshore turbines would disrupt whale and dolphin navigation and communication. Wind turbines would interfere with military and civilian air and sea radar and navigation. Their light flicker and infrasound would impair human sleep and health. And what about the trash? Solar panels and wind turbine blades, the length of football fields, cannot be recycled. Where are we going to put them? Who's going to pay for it? Green New Deal con artists simply sweep all of this right under the rug. Scam number 4. The metals, plastics, concrete, and other raw materials for all these wind turbines, solar panels, batteries, and power lines would just be there through a process best described as materials acquisition for global industrial change, abbreviated as MAGIC, magic. The problem is there's no such thing as magic. Even the International Energy Agency has now finally admitted that manufacturing fossil fuel replacement technologies would require tens of billions of tons of non-renewable iron, copper, aluminum, cobalt, lithium, rare earth elements, plastics, cement, and other materials. That would mean mining, crushing, processing, refining, and transporting tens of billions of tons from thousands of mines, various ores of all different kinds from thousands of mines and quarries using gigantic gasoline and diesel equipment. These fuel-intensive activities often employ hazardous chemicals and release toxic pollutants. They require enormous volumes of water, often in the world's most water-deprived regions. They cause acid mine drainage, create mountains of waste rock, often result in vast lakes of toxic chemicals from refining the ores. Foreign laws governing these operations are often well below U.S. standards. Wind, solar, battery, and electric vehicle technologies require far more metals and minerals than their fossil fuel counterparts. Electric cars, for example, require 3 times more copper than gasoline versions. Onshore wind turbines need 9 times more copper and other materials per megawatt than a modern gas-fired power generating plant. Offshore wind turbines require 14 times more materials. Just that initial Joe Biden offshore wind program would require nearly 110,000 tons of copper, plus millions of tons of other materials. At an average of 0.44% copper in all types of copper ore deposits around the world today, that means just those initial 2,100 offshore wind turbines would require mining and crushing and processing 25 million tons of copper ore, after removing some 40 million tons of overlying rock to reach the ore bodies. Add in materials for solar panels, additional wind turbines, backup battery systems, subsea electrical cables, onshore transmission lines, electrical vehicles, electric heating systems, and other technologies to run the entire USA, and the green energy transformation would require tens of billions of tons of metals and minerals, trillions of tons of ores, trillions of tons of overburden, and thousands of mines, processing plants, and factories. The Green New Deal would require raw materials in excess of the entire world's current and foreseeable mining and processing capabilities. A global Green New Deal would probably require mining the entire galaxy. Green New Deal scam number 5. The United States can outsource all this mining activity, mostly to China probably, without compromising our national security or commitment to environmental protection and human rights. Hogwash. The United States permits very little mining for the metals and minerals that are essential for the energy transformation that climate alarmists demand. Even worse, Mr. Biden, AOC, and their fanatical allies have made it clear that they intend to have nearly all Green New Deals and minerals extracted overseas, often by Chinese companies, which also control the processing of many minerals mined in Africa, Asia, Russia, and Latin America, and the manufacturing of increased percentages of wind turbines, solar panels, and batteries. The United States will go from being a net exporter of oil, natural gas, and refined products in recent years to being almost totally dependent on often unfriendly foreign sources for the materials required for our energy, economy, manufacturing, living standards, health, communication, transportation, and defense. In addition, China and many of these other foreign countries do not apply U.S. laws and standards for environmental protection, pollution control, mined land reclamation, workplace safety, fair wages, child and slave labor, or human rights, which activists demand for clothing and coffee, but not for green energy. Some 40,000 children as young as 4 years old already toil with their parents in Democratic Republic of Congo mines for a few dollars a day under constant threat of cave-ins and exposure to toxic, radioactive mud, dust, and water, just to meet today's cobalt needs, which would skyrocket under any Green New Deal. The cobalt ore is sent to China for processing in plants with equally abominable safety and pollution conditions. They've been linked to alarming cancer, blood disease, and other health problems. An enormous toxic dump for effluents from rare earth mining and processing in Inner Mongolia has destroyed agriculture and created serious health issues for workers and residents. China also uses Uyghur slave labor to build solar panels for sale to the United States. If there have been any calls for responsible sourcing of these critical materials, I sure haven't heard them. Scam number 6. Other countries will follow our lead, rapidly eradicate their fossil fuels, and join America in preventing a heavily hyped but phony climate catastrophe. Fat chance. China, India, and other major emerging economies are doing nothing of the sort. They're rapidly increasing their carbon-based fuel use and greenhouse gas emissions to modernize, improve their people's living standards, and conduct the mining, processing, and manufacturing needed to support our Green New Deal ambitions. That means even if the United States completely eliminated its fossil fuel use and greenhouse gas emissions, there would be no global emission benefits from doing so. But there'd be a lot of human rights, economic, and ecological abuses from this misguided Green New Deal fiasco. Over the past decade, the United States actually significantly reduced its carbon dioxide emissions by replacing coal-fired capacity with natural gas power generation. Meanwhile, Asian and other countries opened of new coal-fired power plants, in addition to those they already had in operation. In 2020 alone, China put 38,000 megawatts of new coal plants into operation. Beijing is also building, planning, or financing more than 300 coal plants in Turkey, Vietnam, Indonesia, Egypt, and other nations. African countries are planning to build more than 1,250 new coal-fired and gas-fired generating plants by 2030 or so, many financed by Chinese banks and built by Chinese companies because woke US and EU banks and companies refuse to do so. Coal still supplies 8% of electricity generation in India, the world's second largest coal user after China. India and Russia plan to mine much more coal and build hundreds of new coal-fired generating units in the coming years. Norway is planning to pump a lot more oil and natural gas. Countless other countries have the same intentions and aspirations. Any American energy transformation would simply transfer emission sources and other ecological impacts from the United States to these and other countries. Worldwide fossil fuel use, greenhouse gas emissions, and pollution would increase significantly. That's eco-imperialism by the United States at its worst. Even if we assume for the sake of argument that greenhouse gases are now the primary factor controlling Earth's climate, there would thus be no climate or extreme weather benefits, even from completely eliminating fossil fuel use in the United States and attempting to replace that energy with wind, solar, battery, and biofuel power at enormous economic, environmental, social, and human cost. So what should you do, and we do? Challenge these totalitarians, refuse to be conned and bullied, refuse to have your jobs, health, living standards, and environment compromised or destroyed. Persuade cities, counties, and states to declare themselves fossil fuel sanctuaries, where Green New Deal mandates do not apply and will not be enforced, where wind and solar installations are prohibited or strictly regulated under the same wildlife and environmental laws that apply to all other projects, including fossil fuel projects. Tell cities, counties, states, and countries to demand independent certification that wind turbine solar panels, batteries, metals, and minerals have come from sources that did not involve child, slave, or forced labor, and were operated in full compliance with all U.S. environmental, workplace safety, and human rights laws. Encourage cities, counties, states, and public interest groups like Schiller and CFACT to file more lawsuits or join other plaintiffs in their lawsuits to block climate change and Green New Deal mandates and junk science. Demand Green New Deal mining right here in the USA. Not only will it create thousands of jobs and reduce our dependency on foreign sources for these critical metals and minerals, it's the ethical, responsible thing to do. Above all, tell your legislators, regulators, climate activists, and other Green New Dealers, you first. You be the guinea pigs for the laws and policies you want to impose on us. You go 100% wind, solar, and battery, and let us watch how it works for you and your families. You be the first to have your electricity cut off when there's a blackout and the last to have it turned back on. You pay the full cost of your climate and energy ambitions out of your own pockets. Then come talk to us. We'll let you know if we're interested. Thank you.
Thank you, Paul. I appreciate the idea of fossil fuel sanctuary cities, where fossil fuels can go and live in peace and provide us with their benefits. So we're going to turn to our discussion period now, and that means we're going to be turning to our panel. That is going to be, I know that there's a couple of, we have one participant I know who needs to leave quite soon, Dr. Greenspan, so we're going to give him one question. And then we're going to turn to Vincenzo Romanello, who we haven't heard from yet, to learn more about his work and his group Atoms for Peace. So let's turn to Dr. Greenspan. Hello, here's our panel. Very good. Hi there.
Hello.
Good. Okay, so it looks like we have Megan DeBroat, Paul Dreesen, Kelvin Kem, Vincenzo Romanello, Nicolas Scaffetta, and Dr. Bennett Greenspan at the bottom there. So our first question will be to Dr. Greenspan. It's kind of a combination of a couple that came in, and I'm going to add a bit myself, so I'll give it to you all at once. Part of the question is about the production that's required to use nuclear medicine. You brought up the molecule of the century, 18-fluorodeoxyglucose, which doesn't sound like it's just on shelves everywhere. Lutetium-177 PSMA, something with some type of gallium, iodine, actinium. These are things used for medical experiments and treatments. Well, how hard is it to make these molecules? Do you need a nuclear reactor on hand to produce them? Are these available to all countries? What kind of infrastructure is needed to be able to practice nuclear medicine?
That's a very good question. Many of these compounds are made in central pharmacies and shipped to hospitals for use. So iodine 131 comes from a reactor, and that's easy to make. And then it's shipped to us in our hospital, and our nuclear medicine department receives it and gets it ready for the patient, so it can be administered. Some of the others are made in central pharmacies and shipped to hospitals. But many of these compounds come either from reactors or from cyclotrons, and then they're shipped to the central pharmacies for further compounding or development, so that they can be made into radiopharmaceuticals that are safe and effective for patients.
Great, thank you. And then just one other follow-up on that, I know you need to get going, would be at the end of your discussion, you talked about precision medicine and having more precisely tailored molecules for different conditions. Do you see this as something where you would actually be sort of producing compounds on demand made for a specific patient? Is it that specific, or is this the kind of thing where we maybe just have a larger stock of things on the shelf?
I think we are going to be developing radiopharmaceuticals more specifically for specific patients in the future. That's some time off, but one size doesn't fit all anymore. And due to clonal variations in tumors and so on, as you could see from that one example where the patient didn't respond to lutetium-177 PSMA, but they did respond to actinium-225 PSMA, we may be able to have a variety of agents available so that patients can benefit from therapies like that. So I think that is in the future, and we'll have to take into account dosimetry and genomics, I believe, to accomplish this. So it's not right around the corner, but I think it's in the near future.
Okay, great, thank you. I know you got to go. If you do have other questions, viewers, for Dr. Greenspan, you can still send them in. We'll forward them on to him to be able to take a look at later. I'd like to turn to our middle guest now, Vincenzo Romanello, who, if you've been watching, you may have noticed you haven't seen yet. We're going to play a short welcome from Dr. Romanello, and then turn to him for a question. And then we do have questions for all of the speakers that have come in. So keep them coming, and let's introduce ourselves to Dr. Romanello.
Hello, everybody. I'm Vincenzo Romanello. I'm a nuclear researcher. I'm Italian, but I'm working in Czech Republic, and I'm the president and the founder of an Italian nuclear association, no-profit association, which is called Atomi per la Pace, which means Atoms for Peace. And this is an organization that we established almost 10 years ago. And in the frame of which we met also the LaRouche movement and the Schiller Institute. And the first thing that we did was an event in Rome. Some of us went there and meet people. We were meeting people in the public in Piazza Navona with some posters, with some informational material, with some papers that we produced, and we distributed some material. Then we made also some public conferences. We interviewed also some important people in Italy and not only, even in the US, among which, for example, Patrick Moore, who is speaking a lot about the green policies and the nuclear. Yes. And we published everything. We also have all the documentation published for free. You can find it easily in Italian, about nuclear, about energy, about renewables, about the need of energy, about radiation, about all this stuff. We have in our website documentation, videos, people can write us and making questions, and all these kind of things. What we learn by our experience is that, however, having a site, having an initiative which is scientifically sound, which is based on truth, is not enough, because not necessarily people will come to you to ask, because the brainwashing of media is extremely strong and effective. We represent an alternative for that people who want to know the reality. So this is our job. But we are fully aware that this is still not enough. And this is why we would like to have a proper networking.
Oops. Well, that ended a little early. That was my fault. It's not the tech team's fault. I screwed that up. So I'd like to ask you, Dr. Romanello, first off, if you're still there. You seem to have turned to a black rectangle. If you are there, great. Okay, very good. Okay, you're going in and out. Here's the question, though. Uh-oh. Maybe we can hear you at least. I was wondering if you could say more about your creation of Atoms for Peace, why you created this institution, what you hope to achieve with it, and why you think it's necessary. If you could give us an introduction to that, that would be much appreciated. Oh, yeah, please unmute your... If you mute yourself, we can't unmute you from this side. So.
Can you hear me now?
Yes, go right ahead.
Fine. So the reasons and how it was created is more or less described in the video, but what I would like to add are three things, maybe, which could be interesting. The first is that we do not use any, we would have rights, according to Italian law, to some public financing, to some public money. We refuse any public money. This is the first thing, and we are very proud of it. The second thing is that we refuse, despite we are not specialists in climate sciences, we refused, and we wrote in our statute that we refuse to exploit any way the climate change argument to promote our discussion. It would be very easy for us to say, look, IPCC and all the media and all the so-called mainstream scientists are saying that we have a climate change due to fossil fuels, so use nuclear energy. We always refuse to use this argument because we think that the first thing that you have to do is to say the truth, to be absolutely scientifically sound. The third thing that I would like to say about our way of working is in our documents, in our videos, we always say, we don't expect you believe us, because we can understand it can be shocking to know the reality, but reserve the same treatment to the others who say the opposite, and check what you are told, because this is the only way you can learn something new.
Great, thank you. For the next question, recognizing that South Africa and Europe are a little further ahead in time than the United States, let me pose the next one and give priority to you, Dr. Kem and Scafetta. I'll put a couple of questions out there and you can address them as you like. They're on the same topic. One question was about, let's see here, Bob asks, various speakers have referred to the Milankovitch cycles as an important cause of climate change. Could you please briefly explain what those cycles are? Also, would anyone like to comment on the research of Henrik Svensmark or Nir Shaviv on the galactic cycles and processes responsible for climate change? So that, and then I just want to put alongside that another question that comes from Manuel, who says, the experts in this presentation have shown us in a very graphic demonstration why no one should pay any attention to what the IPCC people tell us. Manuel's question, how is it that France is moving ahead with building the ITER fusion reactor even though France has joined the Paris Accord on climate change? Are these a contradiction? So the climate cycles and then also the relationship between fusion research and climate change policy. So Dr. Scafetta or Kem, let's turn to just to make a choice, let's go with Professor Scafetta first, please. Oh, could you please unmute yourself?
Yes.
Oh, go ahead.
Do you hear me?
Yes, very well, thank you.
Okay, so about the Milankovitch cycles, those are orbital cycles, so are changes in the orbit of the Earth. So the Earth orbits has a eccentricity, can change. It has the axis that can change a little bit, the inclination of the axis and so on. So those are very long cycles, however. So those Milankovitch cycles are 100,000 years, 41,000 years, 26,000 years, so are very, very long cycles compared to what is important for us. Okay, so we are talking to understand the climate change that we are talking about, which is a climate change during the last few hundred years. We need to talk about much shorter cycles. So Milankovitch cycles don't really matter for these short cycles. The short cycles are mostly due to the sun, as we have discussed earlier, and possibly to other astronomical factors. So we are talking about cycles of 1,000-year cycles, few hundred-year cycles, 60-year cycles, 20-year cycles, 10-year cycles, and so on. So these are all astronomical cycles, and I have demonstrated that actually, these are found in astronomy. All these cycles that are found in climate are found also in astronomy, also in this very short cycle. And the issue is that to understand climate change, we need to understand exactly how these cycles work. About the theory of the cosmic ray, so the sun is able to, of course, if there is a change of solar activity, it changes the luminosity. But the sun is not just light. The sun has also a very strong magnetic field, and this magnetic field varies with the solar activity. So what the magnetic field does is to interact with everything that is electric, so also cosmic rays, which are particles that come from the far, from the deep galaxy. And when the sun is very, very strong, the activity is strong, the cosmic rays are deflected by the magnetic field of the sun. When the sun is weak, the cosmic ray can enter inside the solar system and reach the Earth more easily. And when they reach the Earth, they can produce clouds, essentially. And clouds then will change climate, and therefore there will be a change of the cloudiness of the Earth, depending on the strength of the solar of the sun. All this is missing in the climate models. Okay, so this is one of the several mechanisms that are missing in the climate models. But there is not just cosmic ray. Actually, there may be other astronomical forcing. So, for example, there are dust, interplanetary dust that can fall on Earth, and the dust is brought close to the Earth by gravitational forces of the planets, for example, that are also cyclical. No, so there is a lot of things that are not really known. What is known, what has been proved, what I proved is that the climate system is characterized by a lot of cycles. All these cycles are astronomical cycles. So we need to look at the space to understand climate change. So that is the main issue. But I repeat, the models don't have anything to this and do not reproduce any natural cycles, which means that they don't understand climate change at all. Regarding the last question, I don't know about nuclear fusion in France, no? Fusion, yes. So what I said, so of course there is the hope that we are able to develop this technology. But right now it's very, I don't think that is possible. Perhaps in the next 50 years may be possible. But of course we need to invest in that form of energy. Right now we have other mechanisms like nuclear, normal, traditional nuclear energy that is sufficiently developed so we can use it. But the other form of the energy, we hope to reach the fusion, nuclear fusion, and to use nuclear fusion, because that will solve all energetic problem that we have. But we need to start that.
Great, thank you. Let's turn to Dr. Kem. The same I want to also pose one other question that came in, and sort of feel free to just respond to anything that you've heard. Consider the questions as sort of part of the discussion, but of course, respond to the other panelists as well. One question that came in for you from Samuel is that you said that atmospheric CO2 went up from 0.03% to 0.04%. What if it continues to increase over the next 600 years? Will there be any negative consequences? Will the positive consequences continue? And yes, I'll add that to the mix and ask you, Dr. Kem, to give your reflections on that and other responses to the panel so far.
Well, Jason, first I'd like to mention the sun. It's been comprehensively covered now by the gentleman who just spoke before me. But the sun, the influence of the sun on the Earth, and therefore the probability that it's responsible for any global warming we see, is far, far more likely than any anthropogenic carbon dioxide. Now, often when one says the sun, the antagonists say, oh, it can't possibly be because the heat coming from the sun varies so little that it couldn't do that. It's not the heat from the sun that is the issue. It's the magnetic field around the Earth, which is affected from magnetic particles, charged particles coming from the sun. All of the time, the sun shoots off what's known as the solar wind, and it's just tons of particles pouring out from the sun in all directions. As they come to the Earth, they impinge on the Earth. The Earth has, of course, a magnetic field, something like a bar magnet, and it comes down to the ground, so to speak, at the North Pole and down to the ground at the South Pole. And that's what gives rise to the famous northern lights and the southern lights, as you can see in the Antarctic. When these charged particles strike the upper atmosphere and go through the magnetic field, some of them are driven downwards and they create those lights, the northern lights and the southern lights. So that's where you can see this happening. Now, as the magnetic field of the Earth interacts with these charged particles coming past, its ability to screen the Earth alters. There's also other charged particles, cosmic rays, coming from all the other stars in the universe that are coming in as well. As the magnetic field of the Earth strengthens, it causes less of these rays to penetrate, and when it's weaker, it causes more. And that varies the amount of cloud cover that you get on the Earth, which then holds heat in or stops heat coming in because the clouds are in the way. To put it simply, I'm trying to say in very simplistic language what is going on, because there's this big misunderstanding among so many of the public that it's the heat of the sun we're talking about, and it isn't. It's the magnetic field that varies the amount of cosmic rays coming in, which in turn alter the cloud cover. A simple way of watching the activity of the sun is to count the sunspots on the sun. This has been done for hundreds of years now. In fact, from about the middle of the 1700s, it was done very formally, but sunspot counts go back a long time before that can be tracked back in history to ancient Chinese records, and there's some in Mayan culture in South America and so on. So you'll find that the sunspot activity can be very much correlated with the medieval warm period, the Roman warm period, the Minoan warming, and then the little ice ages and so on. So we know that when the sunspots vary and the magnetic field of the sun is varying, we see a result on Earth which leads to global warming or global cooling. And that correlation is far, far stronger than any correlation of human-produced anthropogenic global warming. Now, also, what was the other thing now? You'll find that, sorry, Jason, you mentioned one other thing and now I've forgotten what it was you said.
It was, you know what, I've forgotten it too. Okay, let me turn back. The other question was that you had said that CO2 went from 0.03% to 0.04%. If it got higher over 600 years, would it eventually become a problem, do you think?
From this 0.03 to 0.04. And what happens again, the enthusiasts that push these CO2 arguments say, well, if there's more CO2, it just holds more heat, and like putting more and more blankets on or something. It doesn't work like that. There's a saturation that occurs. And In fact, a good paper was produced on this by Professor Will Happer and Professor Guus Beckhout that we heard from earlier. That if you just double the amount of CO2, you don't get doubling the amount of warming. It's much more complicated, because as the heat photons, the rays of light go up, they strike the carbon dioxide atoms, which is like a stick, and they wobble like this. And you cannot just argue that the more CO2 you have, the more warming you've got. It's far more complicated than that, as the gentleman who spoke before me indicated. And this is why it's so simplistic when people just say the science is settled, and Al Gore and people like that say the science is settled. It isn't settled. But if one wants to see what is most likely from the scientific point of view to be the cause, it's the variation in the magnetic fields of the sun. Now, if we also mention the Milankovitch cycles as well, they're astronomical. And what happens is, of course, the moon goes around the earth and the earth goes around the sun. Everybody knows that. What many people don't realize is the sun's also moving through the Milky Way galaxy. And so it's moving on obviously much longer timescales than the sun going around, the earth going around the sun. But as it moves, there's variations induced by the stars and so on in the galaxy. The galaxy's got spiral arms and so on. And so depending on where the sun is on its pathway, which takes many millions of years, you get these various cycles that can constructively interact with each other or destructively interact with each other. And those can give rise to, for example, major ice ages and that type of thing. So all of this is terribly, terribly complicated. And so anybody who believes that the science is settled and is terribly simple and you've just got to stop burning coal, it's very simplistic and it's just plain and simply not true. And I don't think that the CO2 is a problem at all. In fact, as one of the speakers earlier on said, if anything, the planet is CO2 deprived. We've seen a distinct greening of the planet that's been taking place over the last number of years as the CO2's gone up. And probably we can double the CO2, triple the CO2 without any trouble. And the benefits would be better crop yields, just more greenery around the earth, but certainly not global warming. There might be some minor contribution, but the big one is almost certainly the sun.
Great, thank you. Next, we're going to turn to Paul Driessen, and just to let everybody know, this isn't your only chance to respond. So we're going to do a couple rounds and sort of just keep it open here. I'm going to add a couple more questions that came in, but feel free to remark on anything you've heard. Sebastian from France asks about how do you envision the transition of petrochemical side of the fossil fuel equation? So claims that we're going to decarbonize. What about petrochemicals? And also Anna asks about electric cars. She says an electric car may not pollute, but what about the power that goes into it, and what about producing the car? So Paul, if you could take those up, or anything else you'd like to say in response to what you've heard from the discussion today.
Correct. Are you hearing me?
Yep, hear you well.
Okay, good. Let's start with the electric cars. Yeah, first you have to make them, and that means tremendous amount of mining for all kinds of metals and minerals in larger quantities and different types of metals and minerals than we've before. So that means far more mining on top of everything we've got to do for the wind turbines and solar panels and the backup power batteries. Then if we're going to have all these electric vehicles, we have to have that many more wind turbines and solar panels and backup batteries to power them up. We need to have much bigger charging systems, not just 110 volts here in the United States, and not even 220 volts, but a much more improved transmission and operating system in our homes, our communities, in order to fast charge these vehicles so that they can be charged up in 30 minutes or an hour instead of many, many hours. So it becomes a very complicated thing. The batteries, when they go bad, can't really be recycled at this time. They get thrown in the trash. I think the manufacturers of the batteries and the vehicles need to take responsibility for those and take them back and find a way to recycle them. So it becomes very complicated on many, many levels, also very expensive on many levels, far more than people are willing to pay. They've done some interesting surveys in the United States and elsewhere over the last couple of years. And even among people who say they're concerned about climate change and want to do something about it, the average they're willing to pay ranges somewhere between $10 and $25, maybe $50 a month or a year that the family is willing to pay. And yet, when you look at what's coming out of Britain in terms of projections for replacing all that equipment I talked about in my talk, all their heating and insulation, their lighting equipment, their hot water heaters and so forth, and running it all on electricity, doing heat pumps instead of gas furnaces, for example, you're talking $10,000, $20,000, $30,000 per family, per household. So the cost to families and businesses is going to be astronomical, and I don't think anybody's prepared for something like that.
I think so. And when you actually ask them, people say no when they have the chance. What I wanted to turn now is, I know Megan hasn't had a chance yet, and Vincenzo's only said a bit, but I want to get a question or a comment that's coming in from Richard McPherson, who we'll be able to bring up in a bit. He's a retired U.S. Navy nuclear engineering officer and was a U.S. representative to the International Atomic Energy Agency on a six-nation panel following the Chernobyl accident. Do we have McPherson? Mr. McPherson? Oh, yes. Hi. Go right ahead. If you have any a question for the panel or a reflection on what you've heard. Is he mute? Can't hear you. Could you please check your mute?
How's that?
Sounds good. Thank you.
Is that better?
Yeah, we can hear you now.
Okay. First, a reflection on this panel. I'd love to have Paul Dresser's speech, because he said what I say all the time. The facts are not heard. The facts are lost in the noise. In 1975, when I was still on active duty, I joined the San Diego section of the American Nuclear Society. One of the things that I've learned since then is facts don't matter to everyone else. And that's really sad. And what I've heard today is a lot of facts, and the facts need to be heard. There was a title in this called, we need 7 terawatts of power. Well, 7 terawatts of power is about 7,000 1,000 megawatt nuclear power plants, which will cost us in excess of $20 trillion. I'm involved with a group right now worldwide, which we know of $38 trillion it's looking to go into mostly energy projects. And the good energy projects are not there for a whole variety of reasons. This whole thing with the IPCC, I became involved in it when I was still at the International Atomic Energy Agency, because they came to us from New York and asked for information from the International Atomic Energy Agency. And the International Atomic Energy Agency had good data on the environment. Our work was entitled Nuclear Fuel Cycle Facilities, the Environment and Public Opinion. To us that made up that 6-nation group, nuclear fuel cycle facilities was easy. The environment was easy. What we spent 50% of our time on was learning about public opinion. And public opinion is what has not been addressed that I'm aware of since 1975 to be able to educate the public about nuclear power, about energy, about the environment. And yet we've given up all that space to the anti-nuclear people. And the bottom line is the anti-nuclear people are promoted and paid for by communists. The reason we don't have the energy security and energy economic security that we could have today after President Eisenhower's speech is simply because the communists don't want us to have it. I think that this panel, this group, this presentation should be heard by everybody in the world. This is the single most informative group or panel that I've ever, international panel that I've ever listened to. And I applaud you all, and I'd like to continue to help as I can. I moved to Idaho in 2015 to retire and learn how to fish. Took them 3 months to find me. So in the summer of 2016, I finally said, okay, they're not going to give up. So I'm going to do what I've always wanted to do, because I'm not looking for a job. I'm not looking for promotion. So I formed a company called Global Humanitarian Resources Incorporated. And Global Humanitarian Resources Incorporated is very simple. We're looking for individual solutions under the nexus of agriculture, water, and energy that will never see the light of day for a whole variety of reasons. But by combining them with other solutions, we can create executable solutions that take agriculture, water, and energy and work together. And that's what the world needs. And the environmental consequences come with that. The environmental consequences are better. Everything I've heard about the complaints about CO2, global warming, et cetera, they're all bogus. I know that. I know hundreds of researchers, good researchers that have been involved in this process for many years. I believe all of you. What we've got to do is we've got to somehow educate those other folks. One of the things that came to me in 2018 was, while we were working with soils and water, was I was introduced to Dr. Paul Marotta. Well, I never knew Dr. Paul Marotta, even though he worked for the US Navy. He designed nuclear power plants in upstate New York for the US Navy. Paul was bored because the Navy didn't have any new nuclear power plants to design. He went out on his own. He knew what the country needed for security. So he has designed something called the molten salt nuclear battery, which will be a reality in a couple of years. We combined his technology with what we were doing with we call combined heat and power for greenhouses. And with a man up in Montana who started life as a farmer, grew up as a farmer, had a great life in business and was very successful. He knew that the answer was in soils. His name is George Gersema. So he started working on soils so that we can grow crops faster. We can reduce the need for insecticides, pesticides, herbicides, all those other sides that I can't pronounce. That's why I'm a nuclear guy, because I can't pronounce all those other words. I've watched George in the last 3 years take a plant that was in the best soil that he had. He got 2 feet. Last year, he got the same plant in the same period of time, 3 months, grew 9 feet. So we know that the answers are available. And the answers are available in all of these countries where you talk about 30-some countries that people need food and water. It is available with the technology we have today right here in the United States between Idaho and Montana. And it's not that expensive. So we can go take these technologies to other countries. We can help them get the water. We can help them grow the food to feed them. And there's no excuse why we're not doing it. Thank you.
Okay, thank you. Thank you. Okay, I see just from emails, we've got a couple of some time issues. I do want to turn to Megan next, then hopefully we can get one more comment from Paul. And Mr. McPherson, we will send you Paul Dreesen's talk. So here's two for you, Megan. One of them is about the Great Oxygenation Catastrophe. and or the Great Oxygenation Event, where I guess it seems like from what you described, cyanobacteria performed a mass genocide and killed most of the life on the Earth, which sounds like a terrible fascist plot to me. Wondering if you could say more about how the biosphere, that's pretty brutal if that's actually what happened. If you could say how that's a good thing, if it's good, or what that tells us about the biosphere. And then here's a question that comes in from someone in New York that I want to tack on to that. Alexander Hamilton, in his paper on the subject of manufacturers, said that division of labor would increase as technology became more advanced. This would require population growth, as Megan has shown. It seems that in a healthy economy, losing people could have bad economic consequences as opposed to increasing consumption. Is there a good rate of population increase? So the cyanobacteria versus population growth, do these contradict? Does this say something about economy? Pull it all together, please.
All right, I'm going to have to answer them separately instead of combined, but in terms of the Great Oxygenation Event, I think it's a great paradox. I mean, and you look back through the geological record, and there are, I think, 5 great extinctions. 2 of them are pronounced. This Great Oxygenation Event is the biggest, most destructive of them. I think it points to a certain irony. It's really fun. Yes, these cyanobacteria pumped out this toxin, which even they couldn't abide, and wiped out most living things. But there's a process of evolution of the system of the biosphere as a whole, which is above any of the particular species. And this is an important thing that Vernadsky really brought to light, which is in a direction of growth, it's in an anti-entropic direction. And so the catastrophe of the moment seemed to yield a system, a new system of creatures which had a higher potential than the dominant creatures that existed before this mass extinction. And that's also true if you look at the KT extinction, when I pointed out with some of those charts. So I think it's really a delightful aspect of the evolutionary process. There is an unfolding process of the development of life, which isn't just the sum of its parts. And we're the only species that's able to consciously reflect on that and then consider what is our role in that. And then in terms of what was brought up about population growth and the fact that, Hamilton observed that with a developing economy and further division of labor, you need more people. Yes, you need more people. There's not a number you could give to the right rate of population growth. If you study Lyndon LaRouche's discoveries in the science of physical economy, what he concluded is that the important thing is a system of inequalities where the particular finite number is not what's important, but what's the trajectory? Is the rate of increase growing? Is the rate at which your economic profit, and he didn't mean monetary profit, he meant profit, what he called free energy, right? Profit that could be reinvested to grow. Is the rate of the growth of profit growing? And if that's growing, then naturally there will be a growth in the population. And that's the measurement of a healthy economy. So you want to look at this rate. And I think the thing that always alarms people at first, because of the brainwashing we've all had to endure, is the idea of unchecked, unending population growth. But there has to be a limit somewhere, right? Says who? I've never seen any evidence for that.
Great, thanks. Let's turn at this point, and then we can go to a show of hands. Paul, I don't know if you'd like to respond to what you heard from the previous speaker, or just offer any last thoughts. I know you need to get going, so if you'd like to say anything else, take it away.
Let me jump in just a little bit from the perspective of someone who's been to Israel multiple times. You wouldn't think a desert area like Israel, the Arava Valley, the Negev, and so forth, which receive about 1/4 the water in a year that Phoenix, Arizona, the greater Arizona, New Mexico area does in the United States. You wouldn't think such an area could support so many people. But the Israeli drip irrigation technologies and many other technologies, that greenhouses and so forth that they've put into place in those areas, provide almost half of the food crops, the vegetables and fruits of Israel at this point. They're exporting well out of the valley and way into Israel and into Europe. So it's an example of how an area that is most inhospitable to humanity and to animals can still become tremendously fertile with the right application of this stuff in between the walls of our head, our cranium. Human ingenuity, innovation is incredible. So there's nothing in that perspective that limits the population, but it does say that we can put a lot of people into small areas and create the energy we need, the food we need, water from the sea. The desalination plants in Israel provide 80% of all the drinking water, and it's probably at this point, by the end of this year, it'll be more like 85% of all the water they drink there. So the limits to growth there are really within the political realm and the realm of our own creativity. If we circumscribe the amount of energy or water that we're allowing people to have, that has an impact on populations, on people's ability to improve their lives and living standards, their health and well-being. But if we get the politicians and the radical alarmists out of there, the ones who are trying to scare people all the time about climate change and what have you, the limits to our own abilities are very expansive. We can do a lot more than we think we can, and we just need to have the opportunity to debate fully and very robustly, and not have our discussion points cancel cultured, thrown out of the universities, out of the big tech, out of the regular media. We need to have these debates and discussions over climate change, over water availability, over our ability to provide the energy that we need and not destroy the planet in the name of saving it by blanketing our planet with wind turbines, solar panels, and mines. And with that, I'll leave it. Thank you.
Thank you, Paul. No, thank you. Yeah, solar panels are pollution. And so, what's that? Oh,
may I?
Dr. Kemp?
Yes. Jason, I would like to just comment on nuclear power plants, nuclear reactors. When one hears about nuclear reactors, you often have people saying they're far too expensive. And they're thinking about large-scale power stations, which have been the norm for many years. But there's a huge number of different reactors being developed right now. The power stations, nuclear power stations, the last 20, 30 years or so, are typically a couple of reactors that add up to like 2,000 megawatts. They need water cooling, so they're often built on the coastlines, so where you can use the ocean for water cooling. But now there's another group of reactors being developed called small modular reactors. And instead of them being, say, a 1,000, 1,500 megawatt reactor, they're a 100 megawatt reactor. Also, with the larger conventional reactors, you find they only need to be refueled every 1.5 years. So you switch it off for a refueling period. The new small modular reactors, you don't have to turn them off for refueling. You just keep adding either fuel balls into it, or there's the liquid one that we heard earlier as well. So that there's these that are 100, 200, and so on. There's even micro reactors now being developed, 10 megawatts and smaller than 10 megawatts, and various other nuclear ways of producing power. For example, the Perseverance rover, which is now driving around on the surface of Mars, it's nuclear powered. But I want to just link that also to like the concept of a grid, electricity grid. For many countries, you don't need electricity grid if you have some small reactors. When electricity was first started in a place like New York and London and so on, and incidentally, New York was the second city in the world to get electric street lighting. The first was the diamond mining town in South Africa called Kimberley. So in those days, when they started with electricity, there wasn't a national grid. Somebody started producing electricity somewhere and distributed a few blocks and then a few more blocks and so on, and it grew incrementally. We find now often when people refer to the very large African countries that are very poorly electrified, that they say, well, you got to have this grid first. You don't. You can, with a new concept now, have these small modular reactors, and you can put them wherever you want the power. There's two basic categories of them. There's water-cooled ones, but there's also gas-cooled ones. South Africa has the most southerly nuclear power station in the world called Koeberg down by Cape Town, and it supplies power from the bottom up. It was virtually all of South Africa's coal is in the northeast. I'm sitting in Pretoria right now, but the distance between me and Cape Town, where the nuclear reactor is the same distance as Rome to London. So they're conceptually completely different to many European countries. You can't go to some of these African countries that are very under-electrified and say, build an entire national grid to put wind turbines and solar panels and whatever in there before you can electrify the country. A far quicker way is to get a small modular reactor that's gas-cooled. South Africa recognized this, and in the 1990s started to develop a small modular reactor, probably the most advanced development in the world at the time. The team grew to a size of 2,000 people, and it was then put on ice for a while because of anti-nuclear sentiment and the 2008 financial crash in the US and so on. That was called the Pebble Bed Modular Reactor, PBMR. Sometime afterwards, when a lot of the people had dispersed and gone into other jobs, another group started developing a modified version of the PBMR called the HTMR 100, a 100 megawatt reactor. That some of that team is still working in Pretoria today, developing that concept. It's a much faster to construct reactor, cheaper to construct reactor. And ideally, you need something like an HTMR 100 in many places around the world with a radial grid around it that only needs to be 10, 20 kilometers wide. It can serve one industrial area. It can serve one town. As time goes by, you can link a number of these grids up to incrementally improve the size of the national grid. But it's not a necessity to have a massive national grid before you can put something into it. And of course, the smaller reactors are far cheaper and far easier to put in place because these small modular reactors can largely be built indoors in a factory environment. Then the components can be taken out like a Lego set and put together on site. So an assumption that a country has to be very wealthy and have huge sophistication technologically and so on before it can go nuclear is just false. Already there's about a dozen African countries over and above South Africa that have indicated to the International Atomic Energy Agency that they intend following a nuclear future because they realize that some of the other solutions, wind, solar, hydrogen, batteries, is just not going to make the grade for them. So nuclear is available for everybody at various different scales.
Great. I've actually got a follow-up. There's like several follow-up questions on that. And this, I think, will turn to Vincenzo before coming back to some questions about global warming. If you're able to stay on, Professor Scafetta. I know it's late for most of the people on this panel now. Definitely appreciate you being with us. Here's several questions. Zakele asks about small modular reactors. Actually, basically what you were just addressing, Dr. Kem. Zakele says, South Africa was a leader in small modular reactors with its 160 megawatt electric PBMR that was shelved in 2010 and with TRISO fuel manufacturing. What advice would you give South Africa about its pebble bed modular reactor program? We have a question that comes in from Carlo in Italy. He says, I'd like the nuclear scientists on the panel to stress the ability of nuclear fission to provide humanity with clean energy for millennia, especially by means of the fast reactors, I presume breeder reactors. We also have a question from Miguel. Miguel says, today in Spain, he says, it's not possible to store energy on a large scale. This is a great problem in physics. So the solution is to make energy through continuous production, natural gas, carbon thermal power plants, nuclear plants. If we use renewable energies with production that's discontinuous, we won't have energy for all. Vincenzo Romanello, if you could address anything you'd like, or including small modular reactors, pebble bed modular reactors, the benefit of having continuous production of energy, and what I'd really like to ask you about is about having nuclear fission over the long term and the role of fast reactors and how that technology would be a benefit.
Well, let me start with one simple example. So this is a pellet which weighs 7 grams, okay, of uranium oxide. It can produce the energy that can feed the needs of electric energy of average US citizen or European for 1 year. This pellet of 7 grams costs around $10. Well, this is the present technology of the present reactors. And we have to understand how this fuel is obtained. To obtain 1 kilogram of this fuel, we use 10 kilograms of natural uranium. And of this fuel, so after getting rid of 9 kilograms and using only 1 kilogram out of 10, we burn only 5% of this pellet. So this means 5% of 10%. If we use the whole amount of uranium that we extract for mines, we could multiply the energy resources, the amount of fissile material, by a factor of 200. So which means we could use nuclear energy not for 1 or 2 centuries, but for millennia. This is the importance of 4th-generation technology research. There were already some examples, some reactors are being built around the world, but of course some R&D is necessary, but much easier and faster than fusion. I'm not saying that we don't have to make research on fusion. I'm simply saying that it would be fundamental from my point of view to use fission technology as bridge technology toward fusion. This is, for example, a pellet of a fast reactor. This would provide the same amount of energy. It is even hard to see. This can produce the energy of 3 barrels of oil or 1 ton of coal. Speaking about the concentration of energy. And this, just to be sure, to be clear, would be the amount of waste, vitrified waste, produced in 1 year by each of us using only nuclear energy. So we are using today a technology which was exploited for nuclear submarines, and it was very useful for them. But of course, it's not the best thing to do for exploiting the resources. On the other hand, we know that there will be a spectacular increase of energy demand in the next years, especially starting from the half of this century. And it was mentioned that we will need 7,000 new reactors. Well, this is a possibility, but you need also to fabricate the manufacturing fuel plants, reprocessing plants, transports, and to exploit efficiently the resources. Otherwise, you can step into black hole somehow. Speaking about the small modular reactors, well, there is this trend today to develop many designs. There are many, and are interesting, of course, because you can reduce the front costs, of course. But we must also think, and in some areas they are very, very good, of course, when you don't have big nets which can transport energy. But let's consider, however, that small modular reactors can be not that convenient from the price point of view, from cost of energy point of view. They are very effective in small countries, in developing countries, in remote islands, yes, but not necessarily everywhere. In some other places, big plants are the better choice.
Great, thank you, thank you. Professor Scaffetta, let me turn to you for some of the other climate questions that have come in. One of them was, one person wrote in saying, this was, well, we don't know who, it was someone on Zoom. They said, listening to the speaker from Switzerland, to the voting result and his explanations on the subject about the CO2 referendum, I can imagine very well that politicians, not only in Switzerland, do not understand at all what they are doing to their countries in the name of climate. This is one comment directed towards you. Another one is that somebody asks, in your field of climate science, given the amount of disagreement, what kind of reception do you, what kind of response do you get from your ideas? So if you present your ideas at a conference of climate scientists, what happens?
Well, that is a very interesting, it's a very interesting question. Now, regarding the first question, how the politicians react to these things, let us say that the things is very difficult. It is very difficult to answer this question because the politicians reason in a way very different from scientists. One politician would like to have certainties. No, he would like to have everything is that everything is clear, everything is certain, so they can make a decision. Scientists instead look for uncertainties, so they put the emphasis on what is not known. Okay, so that is the way how scientists act. Actually, we look for what we do not know, and we try to find the answer to new things. And this makes it very difficult to talk with politicians because they would like to have an answer on everything. And right now, the simplest answer to climate change is given by the climate models. And the models tell us that CO2 is the main driver of climate change and so on. So that is the simplest answer. What the politicians should understand is that models needs to agree with the data. They need to reconstruct climate change the climate change that we have observed in the past. And unfortunately, the models fail in doing this. Therefore, the models are useless, okay, for predicting future climate change or also for interpreting correctly the climate change during the last 100 years. But this is very difficult for politicians to accept. Because then other interests come in. No? So we know that there is a huge amount of financial interest behind this topic. No? A lot of people have invested a huge amount of money, and of course these people would not like to lose money, and therefore they influence also politics. Regarding how the scientist behave. This is very difficult to answer too, because here in Italy we had many scientists who signed a letter where we informed the politician that things were not clear at all. So we have hundreds of scientists from several universities who have signed such a letter. And so many scientists agree with what I say, that science is complex. The science is not settled on this topic, and we need to be very careful about what we are doing. But the politician, I repeat, they don't want to listen a too complex talk. So it is a difficulty, and we need to find a way to communicate with politicians better. Because if they don't listen, or if they just listen to some very naive interpretation of climate change, which is the one given by the climate models, then we will end up in big problems. As I show you in my talk, China is not doing much. And that because there the scientists don't say that climate change is so dangerous. The same thing in Russia. Russian scientists don't say that there is this emergency, this climate emergency. So in Europe instead, in the United States instead, there is some pushing. Another issue regarding politics and science is that in Europe, also in the United States, it seems that there is also a political interference on what scientists can do. So, for example, we know that most of science in Europe and the United States is paid by the government. So it is possible that many scientists just receive money to say what the government would like to hear, to sustain some politics that they have. But I repeat, this is not the way how science should act, and climatic data tell us that we are talking about a very complex issue. And so we need to be very, very careful about this.
Thank you. So what you had brought up about chasing money, or the need to get grant money, and therefore saying things that are going to be received well by the people with all the money. In the case of governments, or in the case of the huge amount of money that's flowing into green things overall. The Bank of England says we got to put the money in. BlackRock says we need to study climate impacts to measure the value of financial instruments. It's a, and then I was just thinking about how on the lower level, you get something as small as, let's say, YouTube putting up warning messages. Like, here's a scientist saying something that YouTube has decided is wrong. Therefore, you shouldn't be allowed to hear it, or you should be ashamed of yourself, and we'll tell you that this is very bad because, a video website obviously should be able to tell scientists what they may and may not discuss. I mean, it's like creating a sense where, you don't even try to figure out what's true. You start to become used to this idea of just, you're told. So, okay, we're coming up on time. What I want to do now is I want to direct one more question to Megan, and then I want to give everybody a chance to offer some final thoughts, and then we will wrap up the panel. So here are the here's what came in that I think is directed. Well, the person wrote it directly for you. So this is Roberto from Italy. He asks Megan. He says, I ask if you envision a growth of population in the universe coming back to a conception of jobs contracts directly under a big public or private program like the New Deal or the work of Enrico Mattei? Or do you imagine that the development of population within the universe, where almost all current and future members of the world's population must make a job by themselves, the cult of the self-made man, which Roberto thinks would lead to no more future other than being the new homeless? So that's one question that comes in. I'm trying to get every question in, even if they're not all answered directly. Another question from Samuel. Doesn't the world need more responsible people? Because even if our numbers are not a threat, our irresponsibility could be threatening. After panel one, I think you might have some thoughts on that. Okay, let me leave it there and get your thoughts on that, and then we'll do a roundup.
Okay, sure. So I want to reference something I said in passing in my presentation, which is Vernadsky's conception of biogenic migration of atoms by technology. So remember, this is where living forms aren't transforming the chemistry of the planet by passing material through their bodies, but actually moving it, changing it. And animals do this very limitedly. Beavers build dams, earthworms turn up the soil, and so forth. but this is really what we as humans do. And one of the important aspects of that is and really what Vernadsky points to as the substrate of the noosphere. It's not just the individual mind, it's also the social organization of man. We change our behavior and we organize society to carry certain things out. Now, one of the very important technological breakthroughs in that domain was the discovery of the republic, a republican form of government. And one of the really beautiful manifestations of that was what Franklin Roosevelt organized in the United States to get this nation out of the Great Depression. And it was his intention that after the war, there would be no more colonialism, and we would work with other nations, show them what we did in the United States, how we did it, and move into this era of great big projects as an incredible social effort of humanity. So that may be kind of a long-winded way of saying, yes, I'm going to keep calling it a technology that was developed in terms of the American Republic and our ability to organize efforts among mankind that no individual could carry out on his or her own, absolutely will have to be the mode of existence of human progress for many, many centuries to come. I can't predict thousands of years into the future what we will have developed, but I think that we can say that with certainty, at least for the next several centuries. In terms of the question of needing more responsible people, the way I'll answer that is, again, referring back to something I brought up, which is what we discussed earlier, these great extinctions. So in the biosphere, there is anti-entropic perpetual progress of the biosphere, but not of individual species. Individual species within that will go extinct. All living matter, forms of living matter, at some point will go extinct as they are outmoded by the biosphere's rate of progress. Human beings are different. We don't evolve biologically. We evolve. What goes extinct with man, hopefully, is not us in a nuclear war, but in the best scenario, what goes extinct are outmoded ideas. We lay to rest and leave behind us unworthy or outmoded, or in some cases, evil ideas. And you want to make a responsible human species, we should leave behind oligarchism forever.
That's something that can go extinct. So I'll read a couple more questions, but you can reply to them directly or not, and then we'll start with, we'll work our way up. We'll start with Professor Scaffetta for closing remarks. These are just a couple other questions that came in. Elliot says, could you comment on the process in Italy about the debates or webinars, the debates on climate change, and the purpose of the letter to the Nuclear Energy Institute that Dr. Kem and Dr. Shanahan have worked on? Why are these developments, why are these debates taking place now? So you can respond or not, but I wanted to put that in the discussion. So Professor Scaffetta, this is your opportunity for everyone to say what else would you like to, if there's anything else that you'd like to say today to our listeners, go right ahead.
Yes, so I would like to say that that is very important that people learn how science really works. And I hope that people will realize that climate science is very complex. It's not settled at all. People should understand why it is not settled. It was not settled because the climate models are not able to reproduce the climate of the past. Therefore, we cannot trust this model in interpreting the climate change that we have observed during the last 100 years. So to understand these things is not very difficult, okay? So often people who look at the data can realize it. So it is not really difficult. My hope is that people will realize these things more and more will realize that we are in a time where, in my opinion, there is an ideological push to do many things in Europe and the United States. I hope that people realize that this pushing, exists only in Europe and the United States. In the other part of the world, the things are quite different. Therefore, we need to understand the difference between reality and ideology. So that is perhaps the most important thing. There is too much ideology on this topic. So when we hear these things from the TV, from the media, from politicians, and so on, we are hearing not about science, but we are hearing about ideology. And I think people should learn how to listen scientists and listen what they really do, to learn how to listen the debate that happen in the scientific circles, to learn what is debated in the scientific journals. And there are a lot of websites in internet that help people to understand in part these debates. So I just invite people to learn more about this topic so that they can eventually convince or force the politician to take the right choices for everybody. So that is my last talk, my invitation. Yeah. In Italy, we are doing something. We are doing something. In Europe, we are doing something. In the United States, many people are doing a lot of things, like yourself. So I am optimistic about this. So, but it will be a long fight somehow.
Great, thank you. Thank you so much for being with us today. Dr. Romanello, your concluding thoughts.
A long career in nuclear research, I certainly understood one thing that is obvious for many of us probably, but it's nonsense for others. And the plain fact is that the biggest resource that we have in this world is not uranium mines, iron mines, or aluminum mines, but it's humanity, it's people. It's their ability to make smart networking, peaceful sharing of ideas, and producing new technologies. This is by far the best and the most reliable and most solid resource, energy resource, food resource, and water resource that we have. The sooner we understand it, the better it is.
Great, thank you. Dr. Kem.
I think a significant problem which has to be addressed now is how to talk to the public. You know, what we've found over the last number of years is that the technology of the news media and of publications in general has gone ahead dramatically. During the Vietnam War, the video footage that came out of the Vietnam War was still on film. They had to film it, race to the airport with a can, put it on an aeroplane, take it all the way back to the US, have it processed and so on. Now you can stand somewhere with a cell phone and you can video something and it can be on world news moments later. So what is happening is that information is being given to the public very, very rapidly, and often in a way that hasn't been interpreted correctly. And unfortunately, a lot of science sounds as if it's easy. So there are far too many people that feel that if they just know some little bit about science, then A plus B equals C, and then they know what's going on. It's far more complicated than that. Earlier, I mentioned cardiologists, for example. You'd never find a group of people in a pub just having a decision on how to do a heart transplant. But there are people in a pub who just have a decision on how to produce electricity, or that nuclear is bad, or something like that. So one of the issues is, how do we get more scientists to talk to the public? And how do we also get the people that are producing the news media, whether it's television or whether it's magazines, whether it's internet and so on, to actually go and talk to scientists and try and interpret the truth? Otherwise, we have enthusiastic people in the public who think they're doing something good and going out and they're spreading the wrong stories, The politicians then want to be where the popular opinion is, so they repeat the wrong stories because they feel it'll gain them most votes. So that's where a snag is at the moment. There's a mismatch between the scientists who actually know what's going on and the picture that's generated in the worldwide media that gets people's attention. So many people have got the wrong ideas, but they don't know that. They're just doing it from a good heart. And of course, there's also the people deliberately trying to manipulate it, who feed in incorrect information. But by far the majority of people are well-meaning, honest, decent people who've just got the wrong end of the stick. And that's a big snag at the moment.
Mm. And Megan de Broat.
I don't have much to say to close, just that I'm very happy and excited with this panel today. I think we should be sure to get it out far and wide, continue the discussion. And I'll just put a call out to everyone watching to organize with us. I think everyone on this panel is in their own way making tremendous efforts to, I was going to say correct the mistakes, but they're not really mistakes, are they? To crush these lies that are really threatening human progress and human existence. A big part of that, I don't want to step on your toes, Jason, but a big part of that is going to be what we discuss tomorrow morning in the third panel on the state of the financial system, in which much of this green genocide policy is centered right now. So I would just call on everyone to organize with us, do the work, and join in these efforts.
Well, you know, I'll step on even more toes. I'll also mention the fourth panel of this conference that's tomorrow afternoon, which is also good for everyone to know about. Tomorrow morning, at 9 a.m. Eastern U.S. time, we're going to have a discussion of global Glass-Steagall to end hyperinflation, about the enormous amounts of money being created, the inflation it's generating, and how it simply does not go into really growing the real physical economy. But the fourth panel, I think, addresses something that I think really everyone has spoken about now in their closing thoughts, about the resource of the mind, about having a personal understanding of how science works, about reaching out to the public. Namely, what is a human thought process whereby people can actually come together, figure things out, have an honest discussion. You know, what does that look like? And that explicitly is the topic of the fourth panel of our conference, which I think is going to be good to sort of directly address this. You know, how do you have a real dialectic? I'd like to give the final word of our panel here to Lyndon LaRouche, to some brief remarks that he had made about the you know, Megan, you had talked about how some things should go extinct, like oligarchism, you know, maybe like the anaerobic creatures that existed before the great oxygenation event. You know, LaRouche in this discussion is speaking to I'll just say what the setting is, that he's speaking to a group of young people interested in his ideas and in his presidential campaign. So let's play this 2-minute clip and then we will close.
And it's in that part of our life, in our determination to express that into a future which exists beyond our death. That is the meaning of human life. And the problem that you have in your generation, you are young adults, where an older adult generation has failed existentially. There may be individuals in the older generation who have not failed, but the generation as a whole, especially the white-collar generation, has failed. They failed catastrophically. Your job is, because you are receptive to these ideas of principle, to the notion of the individual as immortal, an immortal personality, despite the death of the mortal body. It is your destiny, your responsibility to guide the changes which must occur in society if society itself is to survive. And therefore your generation has a unique historical role in the existence of mankind as a whole. And to understand this in yourself and to see your identities as so situated is my mission for you. Thank you.
So I'd like to again thank the participants in our panel, Professor Nicola Scaffetta, Dr. Vincenzo Romanelli, Dr. Kelvin Kem, Megan de Broat, and Lyndon LaRouche. We'll see you tomorrow for the second day of our conference, and until then, ask you to bring your friends to it and to become a member of the Schiller Institute and join in our work. Thank you for joining us, and see you tomorrow.